Good morning, everyone, and welcome to this third session of the industrial workshop of the EUNICE week. My name is Gabriel Moncalian, and I am the academic director of EUNICE at the University of Cantabria, and I will be today's moderator, the moderator of this session. Today's session is about doctorate in EUNICE. So in the session, we will mainly talk about industrial PhD programs in our 7 universities, but also about general PhD, as you will see, because some of our universities do not have proper industrial PhD programs. So the main objective of this session is to know about both kind of programs in the 7 universities of EUNICE, with some of example coming from some of our PhD students. At the end, it is true that the degree is going to be the same in all 7 universities. The competences are going to be just the same for all our PhD doctors, but the way to obtain the degree is quite different in all the different universities, and at the end in all our 7 countries, and as we'll see today. So that's why we have prepared this session in order to put in common our similarities and differences in order to learn how the PhD programs are done in our 7 universities. After each of today's talk, we will have some time for questions. So you can write your questions at any time in the Zoom chat or in the YouTube chat for all of you following us in the streaming, or even you can raise your virtual hand at the end of each talk. So after this introduction, it is my pleasure to introduce you to our first speaker today, who is Dr. Maria Victoria Biezma. Maria Victoria Biezma is professor in terrain and material science and engineering at the University of Cantabria, and she is an expert in corrosion of materials. But today she's here not as an expert in corrosion of materials, but because of her expertise in the supervision of different industrial PhD students. So her talk today is about PhD students and industry looking for a synergistic environment to do an industrial doctorate. Thank you very much, Maria Victoria. The floor is yours.
Thank you to you, Gabriel, for your nice presentation. And I try to share my presentation. Can you see it?
No, not yet.
Not yet. Well, now?
Now it's coming. Yeah, perfect.
Now.
Thank you.
Thank you. Good morning to everybody. Yes, Gabriel told about the aim of my presentation. You have here my mail in the case that you want to do any question. Yes, first I consider interesting to define what is a PhD. PhD could be defined as an original research work prepared by a student in any field of knowledge. So PhD students are, we know that are in the last stage of the university academic level. They have needs, but they have obligation and should commit themselves to the society. Bear in mind that they are subject to different rules that the rest of the university is studying. It's important to remember. So this student can obtain in industrial companies a wide opportunity to develop their thesis work in a real environment. So a student, industrial companies, and the university as institution could benefit from this mutual synergy. So we are all the package of this important mix. So attending industrial PhD program, we know that almost every European state have the industrial program related to provide this opportunity to a student. The objectives and protocol are quite different between countries, but they share nevertheless the common interest, making the industry aware of the advantage of widened access to the PhD student. So the industrial PhD student, a PhD really is an effective bridge between academic and industry. So the 3 members, the 3 elements, student, companies, and university must create mutual synergy and will appear the concept of triple beneficiaries or win three. So to pitch the student on the job training. So a student is balancing between academic in situ per se, wherein could obtain the future employed in this institution, wherein acquire systematic scientific research, and meanwhile industry could provide an employee in these companies and offer technology management, business, and etc. Attending our program and in University of Cantabria, wherein my colleague Rebecca will speak later about it. Literally, it is the aim of this program to promote within companies the training of PhD in research solvency programs of the University of Cantabria by financial support in any area where scientific, technical, or technological knowledge linked to business and industrial activity. You have here the link. Which are the data update? Currently, we have 31 students that have this grant, this scholarship of this support. 5 while a student has present the dissertation of the thesis, and current is developing 21, and it's important to point out that 5 students has abandoned the PhD due to different reasons, mainly to incompatibility with working areas. So in this case, to obtain more data, important to point out that the financial support means 25,000 euros provided by Banco Santander at our institution, University of Cantabria, via project within a research group. And the immediate question, what does cover this financial support? A lot of things. Fungible material, trips, attendance to congress, seminars, all experimental studies, payment of PhD thesis, etc. and etc. So cover a lot of activities, and a student can be sure that will end the thesis with all guarantees. So the aim of this presentation is to know the opinion of potential future doctoral students and companies attending thanks to a previous study that had present in the Congress Edulen, and analyze how this student can fulfill the interests of the industry. It's important to point out also the careful selection of the student is crucial to the success of doctoral project for both academic and industrial partner. And I want to say that there is a few information in reference about this topic, but I want to point out the work, excellent work of Kilender. The methodology was based in 2 questionnaire surveys related to or sent to 2 groups. Group 1, when sent to PhD student, a master PhD student as potential future student, and group 2, companies that could be involved in a PhD to know it is possible to break this important concrete theoretical barrier. The participation was really high. It's important to result 30, 75 and 85% respectively is really important. And 5 days average time for answer. The question were all deterministic, yes or not, or open, wherein the open-end question, wherein the people have the possibility to add any comments. Here you have the question for the first group, a student related to industrial PhD. Very simple question, but very carefully selection the question. Do you know industrial PhD, yes or not? Do you think enriching that university and companies work together in the supervision of an industrial PhD? Yes or not, and comment, important. These two questions are common for the two groups, and we will analyze together. And the third question, what does it mean for you, a PhD? A PhD is important to know because as this kind of, or this group of students are very particular. Increased knowledge, social benefits to find a qualified job, interaction with colleagues or others. The survey sent for industry related to industrial PhD, in general, both groups very linked with a scientific, technological environment. The first question, identical. Do you know industrial PhD? Do you think enriching a university and companies work together, supervision and PhD? But the format, the last one, excuse me, are different. Are you ready to start an industrial PhD program collaboration with university? Yes, not, and comment. In the case of collaboration, what would you get? A benefit or a necessary cost is important to know and think about it. And the last one, would you make your company's research available to doctoral students directly or indirectly? Yes, not, and comment. You can see that there are very possibilities wherein the people introduce important opinion. So in order to analyze the result and to put together the identical question 1 and 2, do you know industrial PhD? A student, 80% of students say yes, but 20% no, so we must work on it. But companies, please put attention, around 50% say yes and 50% say no, so we must work in deep about it. Attending the second question, do you think enriching that university and companies work together in the supervision and industrial PhD, both groups are very, very similar? Yes, categorically, yes, they are agree in this aspect. Attending the question, the third question for the student, what does it mean for you, a PhD? Do a PhD? Please put attention. In general, increase knowledge, but the student can mark more items, no exclusively, no one. So the second one, obtain a society benefit, then interaction with colleagues and others. In others, for example, in minor people say obtain a higher salary, but this is the few percentage. Which are the important comment obtained not for all PhD students, a selection of industrial PhD students, because this survey was not only sent to Cantabria University students, was extend the questionnaire to another university, another college. So here you are, the main comment. After or during the develop the industrial PhD, to practice a real environment of potential future job. For example, another one has covered this experience, cover all my expectations. I feel very proud with myself. Another one, very interesting to analyze in this context of today, I consider that an international tutor for industrial PhD is a real added value for everybody, a student, partner, and university institution. Another one say, I only want to say thank you very much to the company and university that provide me all the tools to finish my PhD. Another one, for example, it's important to point out this opportunity has provided me the chance to touch a higher position in my company and literally say a rare case in my country, Spain. And another one, for example, point out the importance to combine, meanwhile, develop the industrial PhD to impart lecture, labs, exercises, so it support to the professor during academic activity. Attending all the company result, the question 1 and 2 just has been defined. And the question 3, the question 3, do you think enriching to start a collaboration with university in order to this program, when in the context of this program, please put attention. 60% say yes, but 40% say still no. So we must repeat, train on it. Attending question 4, what do you mean for you? Cost or unnecessary or benefit or unnecessary cost? In general, 30%, yes, a benefit. And the last one, would you make your company research available to doctoral students directly or indirectly? They say yes. They say a very positive answer. The comment of the attending this question, the last question 5, the most important comment that include or suppose 65% are related to obtain qualified personnel and increase competitiveness in the industry, in the company. So they are prone, open the mind and are thinking to increase the quality of the protocol manufacturer, for example, or to obtain a very good image of the company. Attending the comments for the industry in general, I can say that all are high positive. And literally say, I copy and paste, offer possibilities to develop complex and novel projects. There are many research activities that cannot be carried out in the company due to lack of time and resource. And a doctoral student can help fill that gap. It's important. The PhD student may be a possible candidate to join the staff in the future. It's very positive that this conclusion be read by a student also. An incentive for the company, for the point of view of doing more applied research within the industry, applied research, not theoretical. And the last one, companies could gain in competitiveness and project gain a lot with a doctorate that can give more credibility against another companies. But of course, not only is positive, and I pick up only one negative in brackets comment that say the excessive time that they must spend in training and guiding a person who does not yet have experience. So this a penalization that in such occasion a company, a partner say categorically, no, I don't want to participate in this program. So I can, a discussion, industrial PhD can attract talent from the university and increase on the competitiveness on these industries. A student participate in a research project, meanwhile assessing all planning research process in a very detailed and attainable way, so both parties find the necessary benefit. Integrate way of judge approach and theoretical concept and practical application of knowledge be case studies in a real environment, not only in the lab to create some hypotheses, some experimental activities. It's important that the student touch, including hear the noise, for example, in this case, a sheet, steel sheet, meanwhile, is by cutting by plasma, for example, in a steel making company. In all cases, the PhD student read the examples, case studies, and integration of theoretical concepts and practical application of knowledge and highlight valuable, and found the experience highlight relevant also and helpful for the future job. But in this context that we are together, 7 universities in this fantastic collaboration for Finland, Poland, Belgium, and Germany, France, Italy, and Spain, of course. The question is, or could be, is possible an international industrial PhD via this organization, wherein the tutor, student, and industrial partner be of different part. For example, a student for Cantabria University be in touch with a new industry or partner of Finland, or the co-tutor be belong to both institutions, or creates a triple, a reflection or permutation of different combination. It permits us to define or to draw a lot of possibilities. So the importance of industrial this program in its thinking about it. So we should thinking about it, and I invite you that thinking with me or together. It will permit to create links with other professors, tutor partners, companies, and other countries, high motivation to discuss any doubt into a new job scenario with daily real-world case increased relevance to enhance the ability of a student to discuss the PhD study thought interactive approach with new college. It's important. Preparation for future job, who knows, in another language, in another country, encourage out of control, out of comfort zone thinking. So it's important. In very enriching, not only for academic point of view, for personal, a cultural point of view. And in this program, industrial PhD project, are expected to give to PhD students on the job training to gain practically relevant and professional started knowledge and to enhance their set of soft skills. So we should try to create important and reinforcement links together. So now again, and attending my previous and the second slide that I defined the Win3 student partner or companies and university, and we extend to this 7 scenario, we can speak about Winner 3 or Win3 in its 7. So the conclusion of this presentation, of this workshop, is collected here, and I point out the more relevant. All the students that have participated in this study are very interested on this program, and the industry has so to be prone to create synergies. The participants find a realistic existence of this synergistic scenario to do a PhD in facilities environment. So the important key or the important question is that the student is training is work in a very close to the real scenario. So both obtain mutual compensation. The student will feel the recognition of the PhD title during and after research work, and the companies will gain the highest specialist, increasing the reputation and benefits. We must say this, literally say this sentence to the industry, to the partner. So this program should be broader than a short time collaboration. So we must try that to create a thing that is a permanent interaction with university to establish a long-term work. Among all the difficulties that the industrial PhD find in this program, or meanwhile performing a job, it is clear that the chance to link both activities offer a real advantage that is still unexpected in EUNICE scenario. But nevertheless, I permit to do some recommendation because there are some questions pending to resolve. For example, this one: why PhD is available so little outside university institution? Do companies apply a different scale with recruiting doctors? Does a doctor degree guarantee a higher salary in a company, or is it still some broken branches in this part? So considering that the industrial PhD is a developing program, I permit to do an extra recommendation to improve this performance. Integrate the industrial PhD program into university curricula without requiring a student to be company employed. For example, here it's necessary that the student be working in a particular company. So why can't create another scenario? Review the role of the student, university, and analyze the real needs of each industrial sector. The real key is in university that should facilitate a better understanding of the complex state of the PhD. We must be in mind that the PhD, the thesis, is the highest level, academic level for a people in any country. So create, in this context of today, we must work together to create synergy between EUNICE university to promote mutual interest within this program, industrial PhD. So thank you very much for your attention, and thank you for listening and attending this workshop. If you have further any comment, please don't hesitate to touch or be in contact with me. Thank you.
Thank you very much, Maria Victoria. It was a very interesting talk, and I like it very much. In fact, it is a pity that I didn't do an industrial doctorate by myself, because it sounds really interesting and really good for both sides, of the three sides that you said. So I think that we already have a question by Alberto Ruiz Jimeno. Alberto, yes. Okay. Your microphone.
Okay. Hello. Well, thank you very much, Victoria. I think it has been a very nice talk. I have many questions, but I would like one for the survey. Which type of companies you have? How was the selection of the companies? Because I think it's very important to know which type of companies, and if there are pymes or small companies or companies and so on, or if they're technological or not technological and so on. So what was the procedure to select the companies?
In general, this program appear a very good environment between professor and the companies. So it's the first item. And the type of company attending the category in general, it really is in touch with technological and a scientific branch. And attending to the type of company for number of worker, it's in general is a medium or high worker type of industry. So these companies, this partner, usually have a own research and development department. So they are very, very interested on their research. They want to create link because they literally have no time to study, have no time to research. It is the key question.
Okay, thank you. And just I would like to give very, very fast some comments. I think that one of the problems where we have realized, not only here in Spain but also in Europe, is the co-supervision in between the university and the responsible of the industry. This is something which is needed to be worked very much, because it is needed to have a good coordination. If not, the the PhD will be will not have good sensations. No, so this is one thing, and the other comment is about the at the University of Cantabria we started with the imposing, not imposing, yes, in the convocat in the to apply for just for people employed by the company. But was this just a first step, because the problem in Spain is that the number of doctors working in this industry and business is very, very small in comparison, for example, with Germany or with Italy. It's just not more than 17% or something like this. So what we would like is to have more people working in the industry doing the doctorate. But of course, the idea is in the future to have more extensive this program.
Yes, attending your international, the comment of international tutor, I consider that it is highly positive in the factor. My last PhD student in this program was by co-tutor with the College of Technological University of Vienna. So, and the result has been excellent. But so in this, with 7 universities, we have a very, very broad scenario. We can manage this information pretty well. And attending to how many doctors are currently in industry in Spain, really, it's a minor quantity, and we must work on it. But the first institution of the first package that should change this the mind is the partner. Perhaps is the partner, because automatically in another countries to have a doctor implies to have a higher salary, and this case is not the case in our country.
Okay, thank you very much and congratulations for that.
Thank you very much, Alberto.
Thank you, Alberto, for your question. I think that we have a good time for another question by Mar Marcos, who, by the way, is the director of the PhD school at the University of Cantabria. Mar?
Thank you, Gabi. Good morning to everybody. Thank you, Maria Victoria, for your nice presentation, and also for being the voice, or one of the voices, of the University of Cantabria in this workshop. I would like to ask you about the answers the companies gave to your poll when they are asked if they would be willing to join an industrial doctorate program. And they said, half of them said, no, we are not interested in that because we are investing too much time in training students. Was this the only answer they gave? Because sometimes when we have met these companies and we have been trying to promote industrial doctorate, they say that a PhD takes too long time to be written, and that this is too long for them to get results. These companies have their own research departments with researchers working focused on the problems they are interested in resolving. And they say, I mean, writing a PhD takes 4 or 5 years, or if you are working on a part-time regime, these would take 7 years, and this is really too long for us. So did you find any other reasons that could explain their reluctance to get involved in industrial doctorate programs?
I think that the main key to reject this program is that they don't know the real importance and the real impact of this program for its own interest. So we must work on it a lot. So the industry, when an industry with a partner knows about all advantage for them, they say categorically yes. Yes, because all are advantage. Another question and the real situation is the student, meanwhile, is are working in the company have the sufficient time to devote attention to the PhD, to the lab, to write manuscript, to prepare the attendance, any conference, any seminar, and to write any paper with high quality, high impact, for example, is another question. From my experience, my student touch time from Sunday, Saturday night to free access to lab, etc. and etc. So it's important that this is evaluated till now, that the guidelines say the partner must offer sufficient time to the student. But another thing is the real scenario is that the student has no time, sufficient time. And you have seen the number of the people that say bye-bye to this program, 5 persons, is a lot, due in general to incompatibility with the job time. So the important is to be clear the guidelines for the student, for the obligation for both parts, for both and the partner. So and create a real and very, very, very clear for the time zero to the end of the PhD.
Thank you very much, Maria Victoria. Thank you very much, Mar, for your question. And well, I think that we don't have time for more questions. We have to move on to the next talk. But thank you very much, Maria Victoria, again, for your nice and interesting presentation. Thank you.
Thank you very much.
Thank you. So after this presentation, this general presentation about industrial PhD programs, we are now going to have an overview of doctoral programs in our 7 universities. So we are going to start with the University of Vaasa in Finland. And our next speaker is going to be Dr. Virpi Jupo, who is Vice Director of Research Services and the Graduate School there at the University of Vaasa. If I didn't understand it wrong, but now Virpi is going to talk about it, I think that in Vaasa they do not have industrial PhD programs, but she will talk about the, let's say, general or regular PhD that it is for sure going to be very interesting for us. Thank you, Virpi, the floor is yours.
Thank you, Gabriel. Can you hear me and see the slides?
Perfect. Yeah, thank you.
Perfect. Thank you. So good morning on my behalf, and thank you for the very interesting presentation and introduction, Maria Victoria. So my name is Virpi Jupo. I'm here to present, as Gabriel mentioned, the overview of the University of Vaasa and its graduate school and operations. If you have any questions, please send me an email, maybe after the presentation, or contact my colleagues, which I will present at the end of the presentation. And University of Vaasa, I will give a short introduction to our university. We have started our operations in 1968, and over the past 50 years, we have developed our multidisciplinary and international university. We are very small, but that gives us an advantage to be a close-knit and international community. And of course, we have the most beautiful campus in Finland by the sea, and I will prove that to you later on with some pictures. And our core disciplines are business, technology, management, and communications. We have 4 academic units: School of Management, Accounting and Finance, Marketing and Communication, and Technology and Innovations. We are very pleased to have a stand in the rankings in this autumn. Of course, we have several this kind of quality stamps as well. But let's go on, and here you will see the picture from our campus. Some words about our research environment. Almost 1/3 of our academic staff comes from outside of Finland, so we are truly an international community. We are also well networked, and we cooperate with more than 200 universities in over 40 countries, and we are very pleased to be part of this kind of networks and cooperation as EUNICE is. We have 3 research platforms which carry out the multidisciplinary research, 17 research groups, several technological laboratories, And here I wanted to point out one of our star projects, which also has employed doctoral students to be a part of the project. It's Horizon 2020 funded and a cooperation with Wärtsilä and other actors at our region. And here is a link to our research, presenting our research in the university. And of course, the Vaasa as a city is the largest Nordic energy technology hub. And we as a university have been an active part through that hub via our joint projects with the companies and the universities. We have doctoral students who work in the companies and do their studies as a part-time doctoral students. But as presented earlier on, the time and the money are the issues to resolve. We do have plenty of externally funded projects with the industry and other companies in the region. And some of our students are part of those projects. The cooperation is quite often based on the active professors and their connections who do have a joint projects. Unfortunately, we don't have any statistics at the moment on this cooperation, but we are developing our joint cooperation model at the university level to support this industry-university collaboration. And we try to formalize the university level, the cooperation to give the necessary support. And yeah, we see our doctoral students are very active part and valuable researchers and active actors in our community. It's very good result that almost our doctorates are fully employed after graduation. And let's see what we have next. Okay, the graduate school, we have 3 doctoral programs. I will shortly present those ones. And the doctoral school operates at the university level and ensures the support for the supervisors, for the doctoral students. And we try to ensure, of course, we ensure that the students have the opportunity to pursue high quality doctoral studies. We give the doctoral training. We arrange general and introductory courses for all doctoral students, not depending on their field. And all of those studies have been now remotely and of course in English, because you can do your studies fully in English. And here is a link to the graduate school page. And maybe the first one, and I think most important one, where this industry collaboration has been carried out is our doctoral program in technical sciences. Here you will see our fields of science and our research groups. Each doctoral student belongs to a research group and will get a support and guidance from that network. We have 2 supervisors, and the 3rd supervisor can be outside the academia. For example, we have cases if there is a joint project, the 3rd supervisor can be from the company. So that is fully possible for us. As said, at the moment, we do not have industrial doctoral program, but we have plenty of cooperation. But this is still, not clear to us that how systematically this is happening, and of course, what kind of a support we as a university can give to the companies and the students regarding on this issue. And yes, shortly about the other programs, doctoral program in business studies. This is also something that has quite many projects within the companies, not directly technical companies, maybe those as well. But in business studies, we have a long history, and we are one of the oldest business schools in Finland. We have started our operation as a business school. And next one, the last one, is doctoral program in social sciences. This combines the administrative sciences and communication studies. In administrative sciences, we work closely with the communities and other societal actors in the field. And some key figures, as you can see, we are small compared to you, but nonetheless, we are very interested in this kind of a cooperation. It's quite formalized. We have 2 application periods in 1 year. We have 200 applications per year. The intake is roughly 50 per year. It's quite high, but some of them are doing their studies as a part-time. And we have roughly 350 active doctoral students. The number of international doctoral students is rising. That is of course, one of the strategy at the whole university level to have international doctoral students. And also the 4-year graduation is the goal. But as said, if you are working as a part-time in the university and the company, maybe 7 years is more that the reality. But in Finland or at our university at the moment, the study right does not include financing. And of course, this is a big issue. We have employee positions, of course, we have scholarships, part-times and projects as well. But maybe this kind of a cooperation would give us opportunity to apply the external funding to fund the doctoral students as well. Yeah, and here is a link. I think this is quite interesting to see all of our theses. They are openly available from our repository. And contact information, the head of the graduate school is Vice Rector of Research, Mrs. Minna Martikainen. Then we have Niklas and Julie and myself. Here is our joint email address, which you can contact. And lastly, here is a few more pictures for you to know. And we are very, very pleased to maybe have you as a visiting here in Finland. And as I mentioned in the chat box, we had snow yesterday, so the yellow leaves are gone. But even though, thank you for this opportunity to present shortly our university and our case. But I think we are newcomers in this issue, and I'm very interested in hearing your experiences and your insights on this matter. Thanks.
Thank you very much, Virpi, for your interesting presentation. I think that all of us have learned a lot about your system and the PhD programs in your university and in Finland. I think that saying that you already have snow in October it is not a good way to attract people, but well. In fact,
yeah, but well.
Here in Santander yesterday we had like 30 degrees. Just
yeah. That
okay,
can be an advantage or disadvantage.
Good. We already have some questions, in this case by Maria Victoria. Maria Victoria, you can open the microphone whenever you like. Thank you.
Yes, thank you very much. Congratulations for your presentation, Pippi. Yes, I put attention that you are in collaboration with Wärtsilä, isn't it?
Yes.
Yes, and I am in touch with them also.
Yeah.
So it is the moment to create any synergy environment.
Absolutely. We have, for example, this kind of an engine lab when they are, testing their engines with collaboration with Wärtsilä. And Wärtsilä is building their own research hub, not beside the university, but we will have their space and the opportunity to collaborate even further on. So there are plenty of options, I think.
Yes,
Thanks.
Yes, they have installation here also in Cantabria. So it's a very good opportunity. Thank you.
Very nicely spotted. Thanks.
Thank you very much. You are invited to visit us.
Yes, I'm happy to do that and bring my colleagues and researchers with me.
Thank you.
Thank you. Yes, Alberto.
Well, thank you very much for the talk. Well, in fact, I know that you don't have industrial doctorates in Finland, but I know very well that Finland has our goal is to reach the situation between the university and the companies as it is in Finland. So you have already the culture, so it's not really very much needed to have just an industrial doctorate. I have just a very small question about supervision. It's just a curiosity. Have you training of supervisors in your university or not?
Not at the moment, but this is something that has come up from various accreditations, that we should have this kind of more formalized training for the supervisor. Of course, we have this kind of information package within our intranet, having all the information. But I think this is a matter of division on, do the so-called support services does this kind of introduction to new supervisors, or is it a responsibility of the academic community? But this is something that we are now thinking about and developing this kind of supervisor, support. We have supervisor meetings for all of our supervisors. They are roughly 60 from our university. Events where we raise up the important issues and give them a space to talk about what's on their mind. Thanks.
Thank you.
Thank you, Alberto. Mar also has a question. Mar?
Okay, thank you. I'll make a short comment on employability and salaries. It's clear that all over Europe, PhD students, when they finish their thesis, they are full employed. Mm-hmm. And this is really a good news for everyone. And on salaries, it seems that salaries are not that good for PhDs at the beginning of their professional careers. But as time goes on, salaries are better and better for PhDs. And this is because of the competencies they've got, not just their expertise in research terms, but because they've got communication skills and they are leaders and they know how to plan their time and they know how to apply for funds and so on. So after 10 years or so, salaries raise a lot for PhD. This is what reports in Europe say. So this is also good news.
That's so true. And our national survey in Finland regarding all the universities so the same thing, that there is really an advantage to have a PhD. So that is one key selling point, of course. And not of course, not all the graduates can have an academic career. And that's why it's very important to raise these kind of options and these skills that can be transferred from the university context. For example, leading a huge project like your dissertation projects. That's a very good advantage. Thanks. Thanks, Gabriel.
Thanks.
Okay, is there any other question? We have some time until the next talk. In fact, I do also have a question myself, or a curiosity, because you said that in one of the programs, I don't know if in all of them, in the technical science program, you have 2 supervisors per student.
Yes.
Is it common? I mean, is it like a peculiar regulation of this program? Is it common in all the programs, or is it a regulation of the university? And in this way, I suppose that, like, at least in other countries, you have like national regulations, university regulations, and then program regulations. Is it the same thing in Finland? PhD, of course.
Yeah. There are not that many national guidelines. All the guidelines within the university are same for all of our programs. All of our programs, all of our doctoral students, they have 2 supervisors. That's our guideline, and minimum they have to have 2, because something can happen. And of course, some is the professor, and other might be very prestigious colleague, not professor, but some has to be professor. And then we can have the 3rd one outside the academia.
Nice. It sounds good. Yeah.
Yeah. We have regulations quite, in Finland, very strict ones and guidelines for every issue. So.
And how about more than 2 supervisors or 3 supervisors in this case? Is it possible to have, like, I don't know, 3 supervisors or 4 supervisors?
I don't remember cases when there has been a 4th, but I don't see why that's not possible. And of course, there can be this kind of not officially appointed, but your contacting company that, of course, will be like 3rd supervisor or 4th supervisor.
Mm-hmm.
Yeah.
Okay. Good. Yeah. So yeah, I think that there's any other question? No more question. Okay, so thank you very much again, Vicky, for your nice presentation. And now I think that it is already time for our next talk. That in this case it is going to be given by staff and students from PUT, Poznan University of Technology. And it is my pleasure to introduce you to Professor Alina Dovkovniak, who is the director of the Poznan University of Technology PhD School. We also have, I think that Pavel Andrulovnik, who is an industrial PhD working in Poznan in a company called INEA. Is also going to give a talk. He's going to talk about his work in this company and also its relation with his PhD studies. Bartosz Blodarczak. Sorry, I'm really bad in Poland surnames, but I'm doing my best. Bartosz is also a PhD student. I think that in this case is a regular PhD student. And our fourth speaker in this slot is Michal Hiric, who is also an industrial PhD student, in this case working in a company in Aquanet. That is a company working on water-related devices, such as sludge dewatering processes and this kind of stuff. So welcome all of you. I think that first Professor Alina is going to talk, isn't it right? Alina, are you there?
Yeah, could you see my presentation?
Yes, we can see your presentation already. Thank you,
Okay,
Alina.
thank you. Thank you for a nice presentation, nice introduction. Good morning, everybody. I would like to introduce PUT Doctoral School and to present the rules and conditions for education which we offer for our PhD students. The doctoral school was established 3 years ago and educates PhD students within 3 fields of science and 9 disciplines. The disciplines are architecture and urban planning, automation, electronic and electrical engineering, information and communication technology, civil engineering and transport, materials and mechanical engineering, environmental engineering, mining and energy, chemical sciences, management and quality studies. This academic year, the school will educate almost 190 PhD students. And as you can see at the school, doctoral scholarships are financed by the university or financed by the Ministry of Education and Science for students who realize the applied doctorate program, so-called industrial doctorate, and by other projects. Here I have listed the existing regulation concerning our school. So according to the regulations, education at the doctoral school is free of charge and carried out in English, lasts 8 semesters, and is carried out based on individual education program and individual research plan, and finally concludes with submitting a doctoral dissertation. At PUT, the midterm assessment of the implementation of the individual research plan is conducted after 23 months of education. All PhD students receive a doctoral scholarship for a total period of no more than 4 years. The amount of monthly doctoral scholarship is depending on the source and is during the first 2 years, 37% of a professor's salary if paid from a subsidy, it means by the university, or if paid from the Polish ministry program, the amount is higher by about 1,000 Polish zloty. And later, scholarship from a subsidy goes up to 57% and to about 4,500 Polish zloty from the ministry program. And all PhD students have to prepare an individual education program, which includes a plan for obtaining at least 48 ECTS points and professional didactical training up to 60 teaching hours per academic year and at least a 2-month-long internship. Whereas the individual research plan specifies, in particular, a schedule for the preparation of the doctoral dissertation and plan to obtain minimum required achievements in order to be awarded a PhD degree. Industrial PhD students are educated at the doctoral school and their doctoral scholarships are paid from the Polish ministry, as I mentioned before. They also receive salaries paid by the company, research institute, or industrial units where they are employed. Industrial PhD students solve problems and implement new solutions related to the needs of the units, which are also the subject of their doctoral dissertation. At PUT, we do not have a separate path of education for PhD students involved in industrial doctorates. The only difference, as you can see, is that in the individual education program, 10 teaching hours per year are recommended and they work in the unit is accepted as an internship. On this slide, I'm showing you exemplary industrial PhD project realized at the school. In management and quality studies, they focus on practical management and quality problems, the solution of which will improve the functioning of enterprises or improve the quality or product service and service offered. Below, I am giving you some samples industrial PhD project in material engineering. They are mainly related to the development of the deposition technology or manufacturing road for composites. Also on this slide, you can see some examples of industrial PhD project in civil engineering and transport. 4 of them are related to civil engineering and the last 2 to transport discipline, as they aim to assess and reduce emission for rail and road vehicles. And the ministry program offers a special track for artificial intelligence, and PhD studies students represent a diverse set of companies. For example, Roche, a Swiss multinational health company, IBM, Poznań Supercomputing and Networking Center, INEA telecommunications company, and even a huge Polish bank, PKO BP. In this case, usually the goal of the research is to introduce the newest solution from artificial intelligence and machine learning to solve practical problems. Below, I put 3 interesting PhD projects realized with Roche, PKO BP Bank, and IBM company in the discipline of information and communication technology. The last slide of my presentation shows what kind of enterprises and institutions are involved in industrial PhD students project. Some of them are leaders and well-known companies in Poland and abroad. Also, a big group of our industrial partners are the institute belonging to the Łukasiewicz Research Network. Because Gabi already introduced our PhD student, So I would like to say only then they work for the project, PhD project, and their work is really closely related to companies' professional activities. Paweł Andruloniv is from the telecommunication company, and Bartosz Włodarczak, as you can see, is closely cooperated with Siemens company, and both represent information and communication technology, whereas Michał Hyrycz represents chemical sciences. And I have almost finished, but in the end, I would like to use the opportunity and invite our EUNICE members, doctoral schools, academics and administration staff to collaborate with our doctoral school. We have received the STER grant for internationalization of the doctoral school, and we hope your PhD student would like to join IT summer schools at PUT, and your academic staff would like to give guest lectures or become co-supervisor of our PhD student. The project is for 3 years and will start at the beginning of the new year. So I will appreciate it if you decide to become its part. You can find some preliminary information about the project at this link. Thank you for your attention.
Thank you, Alina. So I think that we could have a question session at the end of your 4 talks. So now
Okay.
it is, yeah, if you don't mind, it is the time for Paweł, I think.
Okay.
Hello, everyone. I hope you can hear me.
Yes.
So good morning. My name is Paweł Andruloniv, and I would like to tell you about the industrial PhD program realized in FiberHost company. And during my industrial doctorate, I'm working with 2 supervisors. The first one is Mr. Zwierzykowski, who represents the Poznań University of Technology, and also I have an auxiliary supervisor, Karol Kowalik, who is an R&D manager in FiberHost. And in the beginning, I would like to tell you about the FiberHost and an open access fiber network. Then I would like to tell about my industrial PhD thesis and the topic, and what are the expected results. And at the end, I would like to summarize the industrial PhD program from my side. And I think if you have any question, you can send them on my mail. I will put it after the presentation. And first of all, I want to start with a short digression and tell you why I am using the FiberHost company name and not INEA. And in the middle of summer, the telecommunication operator named INEA has been divided into 2 smaller companies. The first one is INEA, who left itself as the service provider, so the operator that provides internet, television, and other services to both individual and business customers. And the FiberHost as the network operator that develops and manages the telecommunication network and provides the services for other service providers. And right now we realize 2 industrial PhD projects, and that projects has been moved from INEA to FiberHost. And the first one is related to the quality of experience in television systems, and this is my topic. And the second one is related to monitoring and data analysis in access networks. And my point in FiberHost activity is to build an open fiber network across the Poland. And we are building a telecommunication infrastructure that that allows people to access internet-based services. We gave services providers like Orange, T-Mobile, or INEA access to our infrastructure, and then they can provide the services, for example, to individual customers. And the main point is to build the infrastructure only once and give a people choice. So give an access to a few service providers in single household. In standard model in Poland, each operator has to build own infrastructure, and we basically, as fiber host, are infrastructure owner and network operator in the open access model, and then we are giving an access to service providers. And right now we are present in 8 regions of Poland. We want to reach the maximum capacity of the infrastructure that we build to reduce the power consumption and be ecological. And we don't want to build an oversized network. Right now we have about 82% of network coverage. And we have 62 service providers on our network, both countrywide and local service providers. And till the end of the next year, we want to have over 1 million households in our range. And right now it's about 600,000. And the advantages of open networks are the availability of multiple operators. Definitely is a future-oriented technology because you are building the fiber network, the speed of sending and receiving data is the highest, and because the infrastructure is built only once, we reduce the power consumption. And as I said before, we are realizing 2 industrial doctorate projects. One of them is mine, and this is big data analysis of information that comes from set-top box and devices, so the devices that are used to decode and receive the video signal in television services, and the use of machine learning methods to improve the operation of the service and with the customer experience assessment. And the system model will be based on the data receiving from the set-top box connected to the INEA ODT system called Highway. And the analysis and usage of machine learning based techniques in general is aimed to measure the quality of experience level and to find the parameters that might increase the overall satisfaction of the users. And our television system is based on unicast streaming in the last mile and with the multicast technology used in the core network. And we want to analyze the data that comes from the end devices and are connected with television features like live TV, catch up, recording, start over, and many others. And we want to use mentioned data to assess the system condition and stability and add a self-recovery mechanism that can be developed with the usage of such data and artificial intelligence methods. And as I said, the research is conducted on a live television system called Highway. This is our television system that uses HTTP adaptive streaming to deliver multimedia content. And the expected results are that we want to assess the customer quality of experience to deliver a better level of services. We want to create the algorithm that can be fitted to other unicast television platforms based on, for example, Android TV. We expect that we will be able to assess the quality of experience level on a specific set-top box, and the continuous analysis of the television might improve the stability and condition, and we will be able to find faster the source of degradation. And of course, finally, an increase in customer experience will be achieved. And at the end, I would like to summarize the industrial PhD program. And from my side, I think there are a lot of advantages, but it has to be noticed that participation in that program might be quite demanding, because Industrial PhD is, of course, an opportunity to significantly expand knowledge and become an expert in a specified topic. And the company can acquire a new technology. We can, of course, combine daily duties with our research work. But sometimes the overtime work is needed because we can't do everything in standard work time. Of course, high motivation is needed. The challenges are not trivial, and because it's a national program, a lot of paperwork has to be done. I think from my side that it's a great chance for everyone who wants to perform a doctorate and work in the same time. Thank you very much. It's all from me. If you have any question, you can send an email to the email below here. Thank you.
Thank you very much, Pavel. Nice presentation. So now let's move to the next speaker, who is Bartosz Blodarczak.
All right. So I will just share my screen.
Please.
Okay, you should see it.
Yeah, perfect.
All right. Just pointer. Okay. So hello, my name is Bartosz Blodarczak. I'm a doctorate from Doctoral School of PUT, but I'm also cooperating with part of Siemens, previously known as Mentor Graphics. And today I'm going to talk about pursuing a PhD degree with research focused on industrial applications. So a few words on how I got here. I was studying on PUT for 5 years, and during third year, I successfully applied for an internship in Siemens. And once I earned a Master of Science degree, I wanted to further develop my interests in science and in research. And Professor Rajski and Dr. Mrugalski from Siemens with Professor Tischer from PUT offered me to help with my PhD research. And so I joined PUT doctoral school. So what PUT offers me within doctoral school? Firstly, we have lectures with professors from multiple fields of science. And of course, they share their knowledge, and we very often discuss different points of view. Also, they give us hints on research problems. So why we also can talk with other PhD students about publishing related stuff, so any conferences, journals, etc., etc. Also, we get to learn state-of-the-art algorithm, inventions, technologies that are used in modern applications. And studying those things, we can even use those algorithms on or new technologies in our research. And my research is aimed on design for testability applications. So it's about assuring functionality of integrated circuits, chips, designs, microcontrollers. And we are talking about a very large scale of integration designs. So designs that are built of millions of gates. And it's worth noting that there's a new field of design of testability, maybe not new, but frequently the most popular, it's in-field self-test. So the designs must be functional, fault-free, not only during the manufacturing phase, but also during the exploitation. And as an example, here you can see cars, so automotive applications. They are recently built of tons of electronics, and the functionality of this electronics is tested all the time. So when you turn on the car, when you turn off the car, for example, when you stay on the red light, and of course, you everything is tested due to the safety reasons. And other similar applications would be military applications, healthcare, or maybe even aerospace domain. But what's important on research on such design for testability applications is that you need to obtain real industrial designs that typically would not be available for academic purposes. And with help, there comes companies that are very cooperative in terms of research. So for example, you can see AMD, Intel, ARM, Broadcom, or NXP. And such companies provide us problems and background for the research, for example, industrial designs. And we can provide them state-of-the-art solutions. So the work is very cooperative. We share our knowledge, we share or discuss the problems, and thus we can have state-of-the-art solutions. And what about the challenges that are related to the industrial research? So first of all, you have problems that comes from the real applications. So real problems requiring both scientific and technological solutions. So we have typical scientific approach. We need to research, check for any current solutions. Then we obtain our new solution. So maybe it is new algorithm, maybe some circuitry. Then we have to test them on multiple designs and obtain results, generate conclusions. So it's typical scientific approach to the industrial problem. And very often we have first-time solution for the given problem. So thanks to this industrial problems, there are solutions that were never invented before. Moreover, we have complex problems that can be solved thanks to the industrial software or hardware. So there are tools that typically would not be available for academic students. And also computing power is shared by Siemens for me, so I can compute very complex problems within reasonable amount of time. Also, I can work in Siemens office with the DFT specialists. So every time I need some help, they are very helpful, and they help to solve the problems. And in addition, I don't have to worry about funds, as thanks to the Siemens scholarship. And what is the result of studying in doctoral school combined with the industrial research for Siemens? So I have scientific approach thanks to the doctoral school to the problems, to the industrial problems straight from the Siemens or the cooperative companies. Such partnership is the best way to work on the research that results in a wide portfolio of solutions and publications, of course. And the publications are presented in top conferences, top journals. I was, maybe now it's online time for the conferences, but I have pleasure to join such conferences. Maybe due to the non-disclosure agreement, I have extended publication time. But while it might seem as a disadvantage, I think that thanks to the fact that my work might be implemented soon in real industrial products, this is rather a long-term advantage than a disadvantage. and generally working in electronic design automation company that provides outsourcing for other companies, results in having one very good algorithm or circuitry, one very good solution being implemented in chips of every company buying the tool from Siemens. So, for example, previous solution for the problem I'm currently working on is in around 20 billion chips. So I think that's a number, and I consider myself extremely lucky to accept the opportunity to work with Siemens, having pleasure of working with the best specialists in this field of science, and having exposure with solutions I was working on, and also meeting with specialists from all around the world. So thank you for attention, and in case you have any questions, please mail them to me.
Thank you very much, Bartosz. So we're running a little out of time, but let's move quickly to the last speaker from Poznan, who is Michal Hiric. In any case, it is good that you all provided your email addresses in case that anybody has any question, they can write you and ask as many questions as they like. Thank you.
Do you see my presentation?
Yes, thank you, Michal.
Yes, great. Okay. Hi, everyone. My name is Michal Hiric. I work as a search technologist in Aquanet. Additionally, I'm a PhD student at Poznań University of Technology. My thesis dissertation supervisor is Mr. Marek Ochowiak, and my actual supervisor is Monika Pielach, senior search technologist. Before I go over to the details about my dissertation, a few words about my company. Aquanet is one of the leading water companies in Poland. Its activities cover the area of the Poznań Powiat and several communities from other powiats, offering a wide range of several services from collective water supply and sewage disposal to capital cooperation. In the interest of the environment, it also takes care of sludge management and reducing the use of the fossil fuels in favor of biogas. Aquanet, in numbers, we provide clean water to nearly 900,000 people. In 2020, we supply over 47 million cubic of drinking water, and our 6 sewage treatment plants treated over 54 million cubic of wastewater. The length of our water supply and sewage system is over 2,000 kilometers, and their length is constantly growing every year. To better understand the meaning of my dissertation, I will briefly introduce you to the technology of wastewater treatment on the example of our central plant in Kozieegłowy. Sewage flow through sewage system to the wastewater treatment plant. At the beginning, the sewage flowed to the mechanical section where the big solid particles like a piece of paper, sticks, plastics, etc. are removed on the bar screen. In the next step, in the grid chamber, the sand is separated. In primary qualifiers, the organic suspension is reduced. That preclinical sewage flow to the bioreactor, where the bacteria and other microorganisms eat pollution. The wastewater with microorganisms and bacteria flow to the secondary settling tanks, where the microorganisms are separated and returned to the bioreactor. Clean water is diverted to the collector, in this case, Warta River. The sludge from primary settling tanks and additional amount of bacteria are transported to the digester, and after fermentation process, to the dewatering section. The dewatered sludge is set for future processing, such as cement plants or incinerators. Today, the cost of the sludge processing in them is the main cost of treatment process. In 2020, On the central wastewater treatment plant, about 59,000 tons of sludge was produced, and on all our wastewater treatment plants, about 85,000 tons of sludge. The third sludge process in our plants is carried out with the use of the decanter centrifuge. Flocculants or polyelectrolyte is added to the sludge stream, causing the aggregation of fine particles into larger structures, which facilitates their separation. Then, in the decanter centrifuge, the solid phase is separated from the liquid by the centrifugal force. The effluent from the device is returned to the beginning of the sewage treatment system, and the solid is transported to the containers, where is the future transported to the place of processing or management. In the right corner, this is what the sludge looks like after dewatering. The topic of my dissertation is the analysis of the sludge dewatering process from our wastewater treatment plants. The main purpose of the dissertation is to determine the influence of the process parameters and the degree of their significance on the dry mass of sludge from wastewater treatment plants obtained in the dewatering process. The information obtained will be used to optimize the dewatering process and thus reduce the amount of sludge sent to disposal. What are the expected effects of the implementation? At first, increase in stabilization the dry mass in the dewatered sludge. Less sludge to transport means reducing the cost of the transport and cost of disposal. In the case of drying, we have less water to evaporate, and that save heat and energy. It will probably reduce the consumption of chemicals, and the sum of these factors will reduce the environmental impact. Industrial doctorate, how it looks from my side as a PhD student. This program is a great opportunity to improve your professional skills. We get visible effects of our actions and research, so our work gives us satisfaction. I think that industrial doctorates have easier access to funds. Now time to some disadvantages. Multiple overtime work is often looks like you quite work after 8 hours, go home, sit down and read to or write publication for next few hours. It requires a lot of self-denial. Sometimes certain works, events destroy your research plan. I mean, for example, unplanned meetings, breakdowns, illness of coworkers, etc. And finally, there is a little too much difficult documentation, in my opinion. That's all from me. Thank you very much for your attention. If anyone has any question about my dissertation or my company, please contact me by email. And thank you again.
Thank you very much, Michal. And thanks again to Alina for her interesting presentation about the PhD programs in Poland. And congratulations to Pavel, Bartok, and Michal for the excellent examples that you gave us about your industrial PhD studies or your PhD studies in collaboration with industries. I think that this has been very helpful for us. I'm sorry that there is no time for questions right now because we are already in the slot of BTU, but hopefully, or maybe before the coffee break, we could have some time for the general discussion of all these presentations. Thank you again for all the people from Poznan. And now, as I just said, it is the turn of BTU, the Brandenburg Technical University from Germany. And our speaker from this university is going to be Professor Matthias Ziegenhorn, who is the holder of the chair of engineering and mechanics at this university. Although he's, as the other speakers, he's mainly talking today about his experience with the supervision of different industrial PhD students. Thank you very much, Matthias, for being here with us today, and the floor is yours. Hello, Matthew. I think that we cannot hear you. I don't know if anybody else is hearing you. I can see the presentation, but I cannot hear you.
So now.
Wow, yeah, perfect. Thank you very much.
Okay. Wait a minute. It's not so. Enough. Wait a minute. Okay, so I have to introduce our university in some facts. We are not a very large, we don't have many students. We are a small university, around about 7,000 students, but there are a lot of students from abroad, as you see. And we are organized in 6 faculties. And one of them will be now also deal with health sciences. Of course, we are organized, the studies are organized in these bachelor and master programs as usual now in Europe. The employees and the finances is more important than the employers, because it is much more important what we have as money. So the budget, there are 2 parts. One is the budget from the government. It is round about 100 million euros, but very important is the budget from this 3-part funding, because this is very strongly related also to the topic we are discussing today. This PhD works in a relationship with the industry, and you see it is in half of the official budget from the state. It means it is not so small. The international relationship is very improved. You see there is a wide cooperation with other countries, but this is not the topic today. This is much more important for our topic today, research and transfer. We are focused on 4 fields. It is biotechnology, energy, smart regions, and cyber physical systems. Smart regions, maybe I have to explain it, it's clear, but smart regions, it is born and related to our local situation, because Cottbus is localized not far away from Berlin, in a district with old coal mines. And this is the industry which is now on the end. And there are a lot of problems with employment and also with environment. And so there is a transformation process, and that's why we are dealing with the problems of smart regions. What does it mean for old people, for healthcare, for traffic, and all these problems? This is also a research field of our university. It is really interesting and it's new. So now you see what we understand in this field of biotechnology, because it is much more an offer for a discussion later, because we have to understand each other, where are our strong fields and where are the common fields and where are the possibilities of cooperation. Energy, it is of course this very important of this renewable problem, energies. It is not so we are maybe a little bit optimistic in this field. This is smart region and heritage. The smart region I explain you, and heritage it is also very important for, and it is a very strong direction in architecture, because how to organize and how to build up old buildings, and they have a lot of experience, not only in Brandenburg, but also in, as you see here, in Turkey or in Jordania. This is obvious. IT solutions are very important for all of us. So now this research is organized in some projects, and I'm pointing out the most important project, and these underlined projects I'm a part of. At first, digital repair factory. It is maintenance, and this is a very important new point in the industrial development of Germany, that we have to care about our possibilities and to repair also our machinery and use new possibilities of, for instance, 3D printing and the digital world. It means how organize maintenance in our industrial environment. 3D lab, it is also a question about mechanics and 3D printing. Very important is this optimization of this microturbine, because it is related to a new approach for energy and electrical networking in housing and also in industry. Of course, as we are speaking about research, the basics are the studying, and these are the clusters in which the students are improve the knowledge. It is a norm for Germany, absolutely normal schedule. And what is a little bit strange, it is that we have a very strong faculty of social work and also of music. This is they are teachers, especially there. For myself, I'm in the faculty of mechanical engineering and electrical and energy systems. Now about the doctorates, what are possible in our university. In Germany, it is now that a very individual way to achieve a doctoral title. As you see, it's most common in Germany, and it is possible in several ways to go in this direction. At first, you are employed in the industry, and you are able to specificate a topic, and you will find some supervisor in the university. And maybe you was, as you was a study, you was a student in this university, and you have a strong relationship. That's why. And this is the most common way today. The next are these structural PhD programs. It is for students after the master courses, so they are going immediately to this PhD structured programs. And of these programs we have 4. I will tell you about it a little bit later. The founding, because also since doctorates must be founded, we have several possibilities. You know, Germany is organized in a federal way. So we get the money from the Ministry of our land. And the question is how rich is your country or your land? Yes, Bavaria is a very rich one. Brandenburg is not so rich. And that's why we have to look for also other possibilities to finance this research. The structured PhD programs are 4-1. And this could be interesting for you because here is a cooperation possible, obvious immediately. At first, these are this IT solution, resource management. It is the question about environment. The next one I told you already about this heritage. It is much more for architects and civil engineers and power engineers. The most, in my point of view, I am not a part of this four programs, but in my opinion, this heritage studies and the power engineering are the most successful programs we have today. So the question is how research is organized and how research is financed. This slide I did a few minutes before as a result of our discussion how the relationship between the university and the industry is organized. In German, it is much in such a way organized that we are looking for these grants. And we have to look together. As most of our scientific programs are organized in such a way that there must be the university and the industry. The university is financed 100%, the industry from 35 to 50%, and this is a problem for them that they have also organized own money. But it is essential for us to cooperate with industry, because without this cooperation, we are not able to organize the most important research. The duration of these grants are from 3 to 5 years. Most of the budgets are around about 200,000 euro for everyone, for the university and industry. And of course, more, it depends by the program. These are the German projects, not the European. The European, you know for yourself. I have to explain you how we are organizing our research in our country. Of course, this is good, but we have also some frictions because the interests are different. The interests of university, we have to do publication, we have to do research, we have to do, of course, also education. And the industry, they have to do profit. And it is also a question of confidence. Our publication, it is not in every moment in the interest of the industry. And this must be organized very careful, but it works, yes. And so for us, the industry is important. That's why that they give us the impulse. not the idea of the solution, but what is important today. It is not so a question of our own life, but they give us the headlines. Maybe we have much more problem in this basic research, that's why, but this applied research for engineers, it is organized very well. Moment. So now, as a result of our experience, is approach to establish a German-Polish doctoral colleague. The motivation, it's here outlined, it's not so important. We are thinking about this already 1 or 2 years. And of course, for us, it is not so difficult because the distance between Poznan and Cottbus is not so much about 4 hours with car or something like that. It is the relations, the traffic, it is not so well organized, but it is better day by day. So we want to cover it between our university and the University of Poznan. And in the very beginning, we are thinking about our relationship with others and especially with the industry. And because it is the idea of engineers, it is very close to mechanics. Of course, it is possible to open it. And you will see on the Polish side, there are already industries, Volkswagen, EDAC, and on the German side, there are Bosch and Daimler as possible partners, which we are discussing with them. So this is a headline: technology and leadership. It means it is a combination between management and engineering. And because this is, I think, a very important question to establish or to educate young personnel which is able to solve engineering problems, but which is able also to manage some processes. It is not the question to find some good educated engineers, but to find management what is very deep educated. This is not so easy. And that's why it is this combination between technologies and management. And my field is, of course, the mechanical processes. And the mechanical processes we understand as a process of design, simulation, and modeling, with a very strong focus on material and also manufacturing. Very important today, also in the age of simulation, where we have a lot of possibilities. It is the question how we can organize the testing as a part of the quality management. Now here are the possible partners and the partners today, supported by some projects we already did. On our in our direction, there are I show you 3 partners. One is IMA Dresden, which is, and this could be interesting for us today, which is a part of this Applus laboratories from Spain, from Barcelona. It is an engineering company which are very strong in testing mechanical and other parts in aircraft structures. You see this fuselage planning testing, what we did with them. And also Astrofine, it is engineering and technology plant, which is very strong in aerospace technology as a reaction wheel, for instance, for this positioning of satellites. A new partner for us are this medical department of orthopedy. In Poland, the partners will be, or in discussion are, this EDAS and Volkswagen Group. And this, the idea is, and that's why I show you it, and I'm presenting it, to open it for interested engineering research groups. Today, the actual scientific technology topics of us are these hybrid structures, materials, and design methods, and engineering-oriented data flows. And it means we are in the analysis, modeling, and simulation. I show you a result of cooperation between us, what is already existing, and it is existing without a common budget. It is only based on the common interests and on a cooperation in research, that we are informed each other what the interests of the partners, and we are looking for some common fields. This is the question of mechanical, and of course, as I told you, we are looking for very interesting topics in the medical field of research. And so you are on the right side, you will see some models of the bones. And of course, very interesting should be and will be to use artificial intelligence. And here we are trying to do the first steps to understand such structures of bones and sponges better than today. This is just like the demonstrator where we are improving our cooperation and where we are going step by step forward. So that's all what I can tell you, and I can warmly invite for some cooperation, because I think that this EUNICE must be the first step for a further cooperation in research and of course also in education. And I think that it could be a very good possibility to go step by step, starting, for instance, with some common or cooperated master degrees. And of course, in the first moment, we don't have money anywhere, and we are poor all, it's clear. But I think that they will establish possibilities also to start for this European founding. And that would be the target in the end of our cooperation. Thank you very much for your attention.
Thank you very much, Matthias, for your interesting talk. Your talk about your university, your PhD studies, and also the environment of your university. And of course, I cannot agree more with you about this collaboration in EUNICE that we for sure we have to push forward. Is there any question for Matthias? Please raise your hand, or even write your question in the chat or in the YouTube streaming. Okay, good. So if there are no questions, then it is time for a coffee break. and then we'll be back at 11 a.m. or noon for Finland, okay? Thank you very much, and see you in a moment. Oh, sorry. Yeah, there is a question, Mustafa. Sorry, but I don't know. I don't know if Matthias is still here.
Yes, I'm.
Oh, sorry. Yeah, I thought that you left. So I'm sorry. So no, there was no question from Mustafa. I'm sorry. Well, in any case, thank you very much to all of you, and you have all our contacts in case that you'd like to place any question in a later moment. Thank you very much, and see you after the coffee break. Okay, so hello again, everyone. I hope you have had a very good coffee break. Now, so far, we have had 3 presentations from different UNICE universities. And I think that, at least to me, I think that this session is being very fruitful in order to know what the other universities of our UNICE Alliance are doing in terms of PhD studies and industrial PhD programs. So now let's move on to our next speakers, coming from the University Polytechnique de France in Valenciennes in France. And from this university, we have 2 PhD students. One of them is Abbas Salhab, who is an industrial PhD student also working in ST Microelectronics, that it is a company dedicated to microelectronics. And we have another student who is Almami Touré, who is also working in a company, in this case, the computer company IBM. So thank you very much, Abbas and Almami. The floor is yours. I can see already Abbas, who is there.
Yeah,
suppose that you are going to start, aren't you, Abbas?
Hello, can you hear me?
For some reason, okay, no, I can hear you now. Yeah.
Yeah, okay. I'm gonna start.
Just loading your presentation, please.
Yeah. Okay.
Perfect. Now we see it.
Okay.
Thank you.
So, good day, all. I'm gonna present an overview of my industrial thesis project, which entitled Dynamic Characterization of the Wettability of Micro and Nano Structures by High-Frequency Acoustic Waves, Application to Wet Treatments. So the work is done in collaboration with ST Microelectronics, located in the Alp region, as we can see in the left photo, and the EUNICE laboratory at the university, UPHF University. There's 2 locations, so one at the UPHF and the other one at Lille, located at Villeneuve-d'Ascq. So the work is done also between 3 groups of research, the group WET 3DI at ST Microelectronics, and 2 groups of research at the UMN, the BioMem and the Mamina group. So what does ST Microelectronics do? They basically manufacture patterned silicon wafers to be later used in microchips for different electronics products. So these patterned silicon wafers can range in diameter from 200 to 300 millimeter. This process is called the front end of line, which there are consecutively other processes to make the microchips. So what is the direction that the microelectronics industry is taking? So as you can see, there are 2 directions. The Moore's law, which says the number of transistors per chip doubles every 2 years. So basically, we are getting lower and lower in the dimensions. And another aspect is different products, different application, which is currently the directions that the industry is taking. But both directions lead to manufacturing of structures with lower dimension and higher aspect ratios. As you can see, the aspect ratio is the ratio of the height to the lateral dimension. So when we have these kind of structures, there is some problems that the industry is facing today, which basically is the cleaning of these structures. As we can see here, when liquid is introduced to remove contamination from these structures, we can get different wetting states. So we have the Wenzel wetting, which is when the liquid penetrates through these structures, and the Casey-Baxter state, which We have no penetration of the liquid, as you can see also in nature on the lotus leaf. So as an example, we can see here one kind of structure which is called the deep trench isolation, which have an aspect ratio of can reach to 50. So this kind of structure, if it's not well cleaned, can give us defective electronic products, as you can see in the white pixels that are apparent in the image sensors. So our method to characterize the wetting state of these structures consists of using a high frequency acoustic wave up to 5 gigahertz, which are built on a silicon wafer on the backside of the silicon wafer. As we can see here, we use piezoelectric transducers, and we have the patterned interface here and the liquid on top. So basically, we send incident waves, acoustic waves, and we get the reflection. And based on the acoustic energy transmitted on the reflection and analyzing the reflected waves, we can see if the liquid has penetrated to this structure or not, and give ST microelectronics some feedback about the cleaning process. So here we can see at the human laboratory the schematic of the workbench, of the measurement bench. So we have we use signal analyzer. We use a measurement point to stimulate the piezoelectric transducers. Basically, we send electrical signal to these transducers, and we get to stimulate the acoustic waves, and then we get the feedback in terms of also electrical signal. So basically, to approach the cleaning industrial process, so at ST Microelectronics, they use something called the single wafer process to clean the silicon wafers, which consist of putting the circular silicon wafer and dispensing liquid in form of jet. So what we get is a schematic here, which a liquid film is formed on top of the silicon wafer, rotating silicon wafer. So basically, to fit this process to our measurement bench, we use a microchannel. We fabricate a microchannel to simulate the liquid flow on top of this rotating silicon wafers. And we create this flow with a certain, we do some calculation to find out the speed and the different pressure that is undergoing through this microchannel. So what we get at the end is what we call a lab-on-chip system, which consists of PDMS, which is a polymer used for the fabrication of the microchannel. On top of the pattern surface, we have the silicon wafers that we receive from ST Microelectronics, and on the back also we fabricate circular piezoelectric transducer of 100 micrometer diameter size. So this is a photo of an actual wafer which has the PDMS microchannel. So here we can see all the processes for the piezoelectric transducer is done at the clean room at the human laboratory. So we have the photo lithography step, which consists of metal deposition by evaporation and the resin by spin coating and ultraviolet exposure. So it's a positive lithography process. And the deposition of the donor also takes place by magnetron sputtering, which we use plasma to deposit a thin layer of the piezoelectric zinc oxide film. Here also we can see the different process steps of fabricating a PDMS microchannel, which consists of making a master mold by a laser lithography process, in which we use a laser shown here by the bench to make the pattern for the microchannel. Then we use a polymer which named PDMS, which after exposure to heat, it solidified to make the pattern. Then we use plasma here in the photo to make to make the contact between the wafer and our microchannel to bond them together. So here we have two publications which have already made, and other one is already in progress. So some advantages of an industrial thesis consist of experimental work. So usually an industrial thesis include a lot of experimental work and a lot of samples which are we able to, in my thesis, for example, I had the advantage of receiving multiple trainings and working on the clean room and different fabrication processes. Another thing is the travel, so time is fly by fast because I'm obliged to spend some time at ST Microelectronics and some time at the human laboratory, so that's another advantage. And third one is work experience from industry, whether through training or attending different meetings, communications, you receive this experience. And finally, the budget. So you have a significant amount of budget which can be used for conferences, for buying different materials and thesis work. Two disadvantages I can think of is this industrial thesis can include a lot of presentations through different meetings, through different workshops or presentation to the different parties involved. Some other aspect is the communication. When publishing an article or when discussing about different aspects of things, it can take time to take the opinion of the different parties involved. And to conclude, I thank you. And if there are any questions, I'm gonna put my email in the chat so you can contact me. Thank you.
Thank you, Abbas. Very good presentation, very interesting. If there are any questions, maybe they could ask you the questions at the end, like in the previous session. So now let's move to our second speaker from France, who is Almami Touré from UPHF and also IBM. Almami.
Hello, everyone. Good morning. Can you hear me?
Yes, perfectly. Thank you, Almami.
So, good morning, everyone. I am Almami Touré, treat expert at IBM and industrial PhD student at the Laboratory of Automation, Mechanic, and Industrial and Human Computer Science at the Polytechnic University of Hauts-de-France. My research focuses on the collect and analysis of communication flows for the detection of cyber attack. And I started my thesis in February this year with a normal duration of 3 years. So in this part, I will talk about my company, the teams that I'm working, and the tools that we use. My company, IBM International Business Machine Corporation, is an American multinational company active in the field of computer hardware and software and computer service. And now I am in the IBM France entity, and more precisely in a security operation center. So what is a security operation center? It is the team in charge of ensuring information security in a company. So the SOC is a platform that allows the supervision and administration of the information system security by tools for collecting and correlating events and for remote intervention. So the CM Security Information Event Management is the main tool of the SOC since it allows to manage the events of an information system. So in a SOC, there are two types of information to process. The first is events. Events are logs of different equipment such as firewall, router, and server, Windows, Linux, and many others. And in the second part, we have network flows. And the CM focus more on events, and my research work focus on flows. Here we talk about my subject, which is collect and analysis communication flows for cyber attack detection. And this subject can be described in several steps. First, collect low-level network flows such as layer 2 and layer 3 in model OZ. Layer 2 is data link and layer 3 is network layer in model OZ. So we have to collect information of these layers, and after to centralize and correlating the collected flow, and after we can identify security incident from the traffic of information system. So we have collect, centralize and correlating, and after identify security incident. And here, this is the methodology that we are using. The first, we identify three problematic of this context. The first is how to improve prepackaged rule in collector flows. And the second, how to do automation in the intrusion detection system. So how to use behavioral analysis of data and many other type of automation. And the third problematic is how to analyze encrypted flows, which are data used with encrypted protocols such as HTTPS, SSL, FTPS, SSL, TLS, and many other protocols which use encryption layer. So to solve this problematic, we are using machine learning approach machine learning approach like supervised method, unsupervised method, and semi-supervised method. And the main goal is to improve detection and countermeasures against attacks. And after I will talk about you CIF thesis in France. It's an industrial thesis. I am now in the I work parts time between the company and the enterprise. So I'm doing industrial thesis that I can call industrial agreement for training by research in the company. This is a CIF thesis, and it's allow me to have a vision of professional and academic worlds. So at the university, I can discuss the scientific methods and the approach used and adapted to the problem of my context. And after, I can discuss to to the scientific criticism and the different adapted tool. This is in enterprise, but if I am for this, it was in university, but in the workplace, I have the chance to discuss with professionals who use low-level flow collectors, which enable me to have a better vision of customer needs and adapt the scientific method to meet the customer needs. As a result, being successful in making technological innovation. Finally, I can say that the university background is rich of theories, methods, techniques, and strategies, and many more. And being able to use these methodologies in the industrial world become an added value. And it is doubly beneficial for a researcher, me, the company IBM, and the University Polytechnic of Hauts-de-France. Thank you for your attention.
Thank you very much, Almami, for your presentation. Very good presentation. So now I think that we do have some time for questions until 11:30. So is there any question for Almami or Abbas? You can write the question in the chat or just raise your hand. Okay, I do have a question for, I think that you two, the two of you, that is about the supervision. So I suppose that you have a supervisor from the company and then another supervisor from the university, isn't it right?
Yes. As it is mentioned here, in company, my supervisor is the leader of the Security Operations Center. And in university, I have 3 supervisors.
Good. So, and then I assume that you have several meetings together.
Yes.
Yeah, to supervise your work. Okay.
Yeah.
So if I may ask a personal question, so kind of a personal question. So do you consider yourself a company employee or a PhD student from the university?
For me, I guess I consider myself to be more a student of university because, like, I don't do the some work that is related directly to the company.
To the company, yeah.
Yeah, but yeah, it's mostly we receive, like I said, we receive some samples. We work on our subject, academic subject, to investigate the research, different research aspect of the subject. But in terms of administration, I was like, my contract was with the company.
And for how? So if I may ask, for how long?
For 3 years.
Okay, yeah. So good enough to have a complete.
After that, I'm to continue my thesis. Now I have another contract from the laboratory, another one. They gave me another one just to continue to the thesis defense, to the date of the thesis defense.
Sounds good. And how about you, Almami?
Sorry, what was the question?
Yeah, if you consider yourself an employee of the company or just a PhD student.
In my side, yeah. I start my experience in IBM as street analyst. After 9 months, I started the thesis. So I think I am employer at IBM more than PhD student.
Okay,
because I have other activities of treat expert. This is to identify security incident for a customer, and every day I have other activities parallelly of my thesis.
Good, thank you, Almami. We do have another question by Maria Victoria. Maria Victoria, you can turn your microphone on.
Yes, thank you very much for your presentation, Abbas. Just only a question. How did you manage your time to combine your thesis with your current job in company?
In my case, for example, my contract at the company, it was 90% of my time at the laboratory and 10% at the company. So it was basically most of the work was given by the academic director at the laboratory, and the 10% of time it was like when I go to the company site, I receive some trainings, I attend meetings, but it wasn't that the company like enforcing some other work outside of my academic research work.
Do you feel a kind of stress time to time or not to combine these two branches?
No, like I said, the only stress was like it's not stress. It's also can be considered an advantage. It was a lot of presentation to different parties involved, but we can consider that it's not like a disadvantage at all. It's like more of also adaptation to how to expect things if working in industry. Or yeah, thank you.
Thank you very much.
And I also had a comment for Abbas, because if I didn't understand it wrong, you said that as a disadvantage of your work is that you have lots of presentations. Yeah. But I don't know if I consider this as a disadvantage or an advantage, because at the end you have to disseminate your work. You have to present
exactly,
to other people.
Exactly what I said. It can. It's like it's more work, but it's not like it's. I consider it like for me. I consider it like a disadvantage. It's for someone like outside is seeing like I do like for presentation how he sees the stuff, but for me it's not at all a disadvantage. It's something that. I learned a lot from how to present work, how to valorize my thesis, and yeah, it's totally an advantage for me.
Yeah, for sure. I think that it is important for you and also for the company, of course.
Yeah, exactly.
Yeah. Thank you. So, do you have any other comment, Abbas or Almami, about your PhD study?
I thank you for having me today. Thank you all.
Thank you, Abbas, and thank you, Almami. So let's move to our next slot. That in this case is by the University of Mons in Belgium, and we have 3 representatives from the University of Mons. One of them is Dr. Céline Thilou, who is the head of research and technology, the head of the research and technology transfer office there at the University of Mons, and then we have a former PhD student of the University of Mons, who is Lionel Dubois, and a current PhD student, who is Rania Gieten. So let's start with Céline, who is, I assume that he's going to give us an overview of the PhD programs at the University of Mons. Isn't it, Céline? Thank you.
Yeah, thank you very much for this nice introduction. Do you see my slide and do you hear me?
Yes, perfectly. Thank you, Céline.
Yeah, great. So I have some minor comments about industrial PhDs at UMons. And the most important fact is that we do not have a lot of industrial PhDs. It's quite recent and it's not very frequent. So I'm gonna give you some tracks to explain you what kind of industrial PhDs we have and in which proportion actually. So basically, so a few industrial PhDs only. Let's say it's almost 3 or 4% of our PhDs. In Belgium, it's not particularly in Mons, and it's more in Belgium and in the Walloon region, so the French-speaking part of Belgium. PhDs are more based on excellence, and the technology transfer towards companies are done in a further step. So basically, it's not very common to have companies on board of PhDs and to support PhDs. But we still have some possibilities to fund some industrial PhDs. And the first one is done by our research council at the University of Mons. And we co-founded PhDs grants, basically half and half from the University of Mons and half from another partner, which can be a university, an association, or company in every country. So it's very open. So it can be also with your universities. And it's quite interesting. It's one call per year. And we grant, we give around 15 grants each year. So promoter of PhDs need to find a partner. So either an university or a company or an association. And then we write a collaboration agreement and the PhDs can start. So we have a few of them with industrial partners. And then we have more massive industrial chairs, let's say, with several PhDs by agreement. And so, and it's exactly the case of Lionel and Hania, which is going to talk after me in a few minutes. And it's basically with some companies, but also with some association. For example, the last one we started in September 21. It was with the Blind People Association. So it's based on either engineering tools or psychosocial tools for this association. So it's quite large. So we have some industrial chairs. And in a more structural way, we have a dedicated call by our government, by the Walloon region. And so I give you here the link. It's called Doctorate in Business, WIN for Doc, WIN for DOC, WIN for Doc. And it's exactly what you mean by industrial PhD, meaning that you have a PhD student being a large portion of time inside the company, working with the company, working for the company, with dedicated results for the company. And so we have this dedicated call of the Walloon region. And basically, you have to write a project with a partner, and we have an answer in 3 months maximum. So basically, you have a few possibilities to do an industrial PhD in Belgium and the Walloon region and at the University of Mons more particularly. If you have any questions, feel free. No question?
Is there a question for Celine? Thank you very much. Sorry, thank you very much, Celine, for your presentation about your industrial PhD studies. So I was going to ask you that according to the co-funded PhD, do you also have people, employed by the company, but working, let's say, full time for the company, but doing a PhD at the same time? Do you have this kind of situation?
Yeah, we have, but it's very rare. For example, we have around 600 PhDs in progress at the University of Mons this year. And I think this kind of case of people fully employed by a company and doing a PhD besides, I think, if I remember well, it's 2 or 3 people only. So it's very, yeah.
And do you also have like an offer of courses for these PhD students in general for all the PhD students, but also for the industrial PhD students, that if they have to have like, I don't know, 10 ECTS per year or something like that, or they don't have to attend any compulsory courses?
Yeah, they have to do. They have to attend some compulsory courses. It's called Doctorate school, in order for them to validate, to give some credits in order to obtain their PhD.
Mm-hmm.
So we make some arrangements in order to in order for them to be able to attend this course, and it could be course during done during evenings. So we have this kind of proposition, but they have to attend some courses. Yeah.
Okay, good, thank you. We also have in the chat a question by Venerando Gambuza. He says that it is a general question. Is it possible to have a previous experience in a company, for example, to write an experimental thesis for the master and subsequently consider an industrial doctorate in collaboration with the same company? Do you think it could be an idea that can facilitate possible access to the doctorate as well as acquire greater awareness of what you want to do? I suppose that, Venerando, that as you said, it is a general question and probably it is going to depend of each university. But let's see what Celine has to say about it. Thank you, Celine, and thank you, Venerando, for your question.
Yeah, thank you very much for your question. Sure, it helps. We have a lot of applied research PhDs. So if you have first experience with the company and you know exactly your research question and what to answer and how to do it with less risk, but it's still research, meaning that you have to test many things, you have to create some methodology, some algorithm, whatever in your field. But for sure, it helps for this kind of PhD. In Belgium, we have another call from the National Research Fund, which is called FRIA, and it's basically research done in with an industrial objective, meaning that you have to answer a research question useful for companies. So it's not done inside companies, it's not done with companies, but if you write your project towards a real problem in companies, it helps to grant this grant. Sorry.
Yeah, thank you, Celine. Yeah, I agree with you that, of course, it is probably for most of our universities, it is not bad, but even good. I mean, there are no regulations against doing the master degree or the master dissertation in a company and then applying for an industrial PhD in the same company. It could be even good for your work. But I don't know what is the situation in the other universities. Maybe if there is some university where this is not allowed, please speak up and let us know. Is there any other speaker from other university who thinks that it is not a good idea to do the master dissertation and the industrial PhD in the same company? Yeah, probably not. I don't think so.
I don't think so. I never heard about that. Yeah.
Yeah.
For me it helps, but yeah.
Yeah. I mean, you have two sides of the same coin, no? That it helps because you know very much what you are doing, and then you are very well prepared for your industrial PhD. But on the other way, if you like to learn different techniques or different topics, sometimes it is also good to do your master's degree or your master's dissertation in one company, and then move, if you have the chance, to another company to do your industrial PhD. So yeah, it depends on the situation. Good. Thank you very much, Celine, and thank you very much again, Venerando, for your question. So now we have a shared presentation by Lionel and Rania from the same University of Mons. Thank you, Lionel and Rania.
Yeah, and thank you very much for timekeeping. It's very appreciated because I'm jumping from meetings to meetings. So thank you very much.
Thank you, Celine.
Hello, so I suppose you hear me and you see my screen now?
Yes, perfectly, Lionel.
Okay, so I will continue the previous discussion because you were asking, is there some cases where you have performed your master with a company and then you perform your PhD with the company? This is not exactly my case, but the subject of my student project and my master thesis was then continued during my PhD thesis. So it's not a question of being with the company, but more working on the same thematic. And so that could be also an opportunity when you have an interesting student project and then master thesis to continue to work on this. But I will come back to this maybe later. So thanks very much for the kind introduction. It's a real pleasure to be here to present you together with my colleague Rania, our experience in terms of PhD thesis and postdoc, also in my case, in collaboration with industrials. So as mentioned, so we are coming from the University of Mons, as Céline, more specifically in the Faculty of Engineering, and we are working in the chemical and biochemical process engineering unit. We will try to not be too technical in our presentation, so we will present you globally what is the subject of our PhD thesis, postdocs, etc., and then to highlight the interesting points we think which came from our collaboration with industrials. So just to put the context in a few words on our works. So we are working in the context of reducing the CO2 emissions from the cement industry. And as you can see on this graph, cement industry is a large contributor to all the industrial CO2 emissions. And you see it's almost one-fourth of the industrial CO2 on one-third, and in some cases of the industrial CO2 emissions. And so we need to find solutions to reduce the CO2 emissions. And you know that it's a real problem with the global warming. We need to limit the CO2 emissions. And so when we are thinking about that, there are two main categories of processes that we can apply to do this. In one category, we can act on energy efficiency using other fuel or substituting the clinker. So just to say, the clinker is the main component of cement, and this is the clinker productions which lead to the emission of CO2. So we can act on this, but this is not enough. And so in parallel, there is a solution which is called CCUS, which is carbon capture, utilization, and storage. And one key aspect of this process is the implementation cost. And so this is a real challenge. It's the reason why we are working with these industrials in order to help for reducing the cost of such process. Just to give you a global overview of this process chain, you have a picture here. So the idea is to capture the CO2 on an industrial plant. So in our case, this is the cement plant, but this is applicable to other industries, power plants or glass production plants, lime plants. So the idea is to avoid the CO2 emissions to the atmosphere, to capture the CO2, and then to take the CO2 and to transport it to a storage site that could be geological storage. So we can inject under pressure the CO2 underground. Or, and this is something which was a great interest for us, there are different possibilities for using this CO2. You can see here in this small representation, we have these parts here with utilization, and we can convert the CO2 and using this for example, producing methanol. And methanol is the subject of the PhD thesis of Rania, so I will not talk too much on this, but you see globally the principle of this process chain. In this context, I think that was mentioned by Céline in her presentation. So we had the opportunity in 2013 to establish what we call a chair, an academic chair, in collaboration with ECRA. So ECRA is the European Cement Research Academy. Just in a few words, this is a center which is putting together different cement producers which are joining forces in order to advance on different thematics. And CCUS is one of the thematics on which they are joining forces together. And the main objective at EUNICE was really to create a center for scientific expertise in the specific field of carbon capture in cement production and its reuse. And so to promote research and innovation in that field. And so thanks to that, we had different PhD theses, postdocs, but we organized also scientific events, collaborations, communications, etc. You have some picture here, and you see we had also the opportunity to organize some industrial visits. So we have the address of our website here, so don't hesitate to visit this if you want more information. You have here a picture of the global framework of our activities in this share. You see that there are different technical blocks. I will not enter too much in details there. Just to say that me personally, regarding my researches, I was more involved in this part regarding CO2 capture, and my colleague Rania, that will talk just after, is more involved in this part regarding the catalytic conversion into methanol. So that's the global picture, I would say, of the context. Regarding my personal PhD thesis, that was performed just before the ECRAT share in collaboration with a cement company, which is Holcim. And as you can see here, this is a model which was evocated also by Céline. So it's a model of co-funding, so 50% from the university and 50% funding from the company. And in my case, the subject was related to the CO2 capture from cement plants. So cement plants, you know that it generates a flue gas, which contains a certain amount of CO2. And then the idea in my case was to study a chemical processes, which is used to capture the CO2 and which use chemical solutions, what we call solvents. And the objective of my PhD thesis was to identify the best solvents for these specific applications to cement plants. And so I made some experiments, some simulation works. I had also to establish a CO2 micropilot unit. You have a picture here. So this is really a small scale of the process that you will see at the industrial scale. And the idea was to perform different tests with a realistic cement plant flue gas composition. So that was the objective of my PhD thesis, but I had the chance to, thanks to that, to have several contacts also with other cement producers, including ECRA, but also including Heidelberg Cement. And so I had the opportunity to perform my postdoc also on this topic, but on another aspect, so more on the process aspect and technical process aspects. So just you have an illustration here, the processes that you have seen just before with the two columns. As you can see, we can make some modifications on this process. We can add some heat exchanger. We can try to recover some energy. And so the purpose of my postdoc was to simulate these different configurations, to perform also techno-economic analysis. And also, in parallel, I had to perform specific technical studies in relation with CCUS in general. So that was focused on this process. But as I want to say is, in fact, in the process, in my evolution at the university, I started really to focus on one specific aspect. And time after time, I had the opportunity to look to different aspects. So this is for my side. I will let my colleague Rania talk about her work also at university. So if Rania is there.
I am here.
Okay.
So good morning, everyone. Thank you for the kind invitation. I'm Rania Jeten, a PhD student at EUNICE, it was explained. So I'm working on the study of the CO2 conversion into methanol. As explained by Lionel, the CO2 captured is used then mixed with hydrogen to produce methanol. The mixture of CO2 and hydrogen is injected into the conversion unit. They undergo different operations, compression, heating, and so on, to produce finally methanol. Producing methanol from CO2 is a promising alternative of conventional production method, which means that the use of fossil fuels can be reduced, and so the CO2 emissions can be reduced so as well. The objectives of my thesis is the innovation and optimization of this process by combining experimental tests and simulations studies. First, a state of the art is studied by a bibliographic review on the different catalysts used for this reaction, but also the different configurations of the process previously used in literature. Second, experimental tests using these parameters and conditions and different catalysts at a micropilot scale in order to be more closer to the industrial one. From the other hand, simulation of methanol production unit at industrial scale are carried out to have an idea about the performances expected from this unit. It can be optimized by heat integration, and so reducing the cost of the process. Finally, a techno-economic and environmental assessment will be carried in future work to evaluate the process costs and the environmental impact of the overall chain from the CO2 capture to its conversion. So the collaboration with the ECRA has not only provided the funding to PhD thesis, which means salaries and equipment costs, but also communicated to us the real fuel gas data to be used in our simulation and different calculations. It provided realistic assumptions for different calculations. This collaboration have added an industrial vision, which is complementary to the more academic vision of the university, by giving advices in view of the applicability of the processes that are studied.
Okay, so I will continue on the next slide. So we had really the opportunity to have regular meetings with industrial experts, and so that allows us to have very enriching exchanges with different kind of people. When I say different kind of people, this is sometimes managers responsible of industries, but sometimes process engineers or other kind of people. As shown on one previous slide, we had the opportunity to have industrial sites visits. For example, in my case, I had the opportunity to have access to a control room, for example, to see really how the process is controlled. This is not always possible without the collaboration in that field. That allowed me also to have the development of a professional network. This is really useful because the next step of your career, we have to develop some activities, etc. So it's really interesting. And I like to say also it's a supplementary source of motivation to see that your works is concretely considered by the company and used by the company. The company is concretely looking to these technologies, and you can bring some elements to help for the implementation. That brings also some other considerations, market, business, economic consideration, because when you are just working at university, it's not always possible to have these dimensions. That gives also an orientation of the simulations and technical economic analysis for realistic cases. That gives also, that push also important aspects for industrials. I will take the example of a recent meeting we had with Rania. The industrial said, yes, continue to work on heat integration because this is a real interest for us. So it's an example. We had also technical and communication advices during meetings. And that's really interesting because, you know, the advices that we have from the academic aspect and the advices that you receive from the industrial side, it's not always the same. And I would like to finish to say there are certainly more other interesting aspects from this kind of collaborations, but I think we put here the main elements we had in mind regarding our collaboration. So thanks very much for your attention, and I think we have still maybe 4 or 5 minutes for questions. So don't hesitate if you have some questions. We will be happy to answer to them. Thank you.
Thank you very much, Lionel and Rania, for your interesting presentation. It's a very applicable work, so it is a very good example of the collaboration between industry and the university. So as Lionel said, we still have 5 minutes for questions. So if there is any question, please raise your hand or write the question in the chat. Questions for Lionel or Rania or even Celine that is still with us. I do have a question probably for you, Lionel and Rania, that is about the confidentiality, okay? Because of course, to me, the idea of a PhD work or a PhD study is to disseminate the results in publications or in meetings or something like that. But I also understand that in your work that you can have some very interesting results that could be very useful for the company. Maybe the interest of the company is not to share the information worldwide in a way that the competitors could do the same thing. So how do you cope with this situation between confidentiality and dissemination of the results? Is it as difficult as I think, or it is not a big problem? It is not a big deal?
In our case, this is not a real big problem because we are collaborating with the end user, I would say. If our PhD thesis would be in collaboration, for example, with a technology providers, a CO2 capture technology provider or a CO2 conversion technology provider, maybe the things will be different because they will say, no, we want to keep the information for us. In the case here of cement industry, I would say that, and this is the philosophy with ECRA, all the cement producers are almost at the same level. They will have to choose the correct technologies from a technology provider. Maybe we will have some specific points regarding implementations or specific locations, specificities, characteristics. So in our case, that was not a problem. At some moments, we had some exchanges of information. For example, I will take an example. ECRA has specific modeling for simulating oxy-fuel combustion kiln. This is quite innovative, and this is not yet really available. We were allowed to use the data from the models, but we will not allow to present their models or to give too much information regarding their models, you see? So in other words, thanks to discussions, we always find a way for being able on our side to valorize our researchers through publications and papers and conferences while keeping the confidentiality level where it has to stay, you see. So it was important really to have the balance and but all of these are defined at the beginning of the collaboration, at the beginning of the PhD thesis or the chair. So we really discuss with the industrialists, we say, okay, we will do this, and the industrialists have to be aware that as representative of university, we need to publish, we need to present this conference. And so once it is defined at the beginning, I think there is no more problems at the end.
Well, I suppose that it is defined. It is a good thing to define everything at the beginning, but I suppose that in each case that you have to submit a publication or you have to do a presentation, you first of all you submit all the material to the company in order to have their approval to avoid any further problems, isn't it?
In the case of Allsim, so my PhD thesis, that was like this. So we asked it, we say, okay, we would like to publish on this. We sent the paper and he was looking to this. In the case of ECRA, the philosophy of a chair is really to say, okay, we really give the funding to university and this is up to us to manage that.
Yeah.
But you have to know that we have regular meetings. And so most of the time, this is not an obligation, but naturally we keep them informed regarding our activities. They see what we are doing, and so indirectly I would like to say that yes, they will see what we will present in conferences or in papers.
Yeah, sounds good. Thank you very much. Is there any other question? Okay, so thank you very much, Celine, Lionel, and Rania for your interesting presentation.
With pleasure. Thanks very much.
Thank you. So let's move now to our next group of speakers, let's say, that are coming from the University of Catania. And from the University of Catania, we have Professor Claudio Bucolo, who is the Deputy Rector for Doctoral Programs, and he is also the Coordinator of International PhD Program in Neuroscience. We also have with us today Professor Vito De Pinto, who is the Coordinator of International PhD Program in Biotechnology. And we have one industrial PhD student who is Paola Foti, and another former industrial PhD student who is Francesca Lazzara. Thank you very much for all of you. and I assume that Claudio is going to start the presentation. Is it Claudio?
Yes. Good morning, everybody. Thank you very much, Gabriel. Can you hear me?
Perfectly. Thank you very much, Claudio. Under your picture or under your video, it is my name. I suppose that it is a mistake, but well, to let everybody clear that you are not Gabriel Moncalian, but you are Claudio Bucolo.
And then interesting. I didn't.
Yeah, maybe you can change the name, but it doesn't matter. Just let's go to your presentation if you don't mind.
Yeah, yeah, no problem. First of all, it's a pleasure to meet you, Gabriel. This is the first time we meet, and not in presence, but at least in this way. I would like to say thank you to all of you, to the organizer, to you particularly, for your effort to do this event that represent a good one and important event for us in the panorama of PhD European programs. Well, I'd like to introduce briefly the how the PhD programs works in University of Catania, and spend some words on industrial programs. So the University of Catania has actually 19 PhD programs in a large variety of fields, and 8 of these programs, PhD programs, are international programs. We have neuroscience, biotechnology, agriculture, law, informatics, and basic and applied medicine, biomedicine. So it's and then we have inside that the PhD programs, of course, in other fields, with a tight link with other European abroad universities. So maybe in the next future, the other programs will change the status in international programs. Neuroscience, for example, I talk about my program, the program that I coordinate. It's related to neuroscience. Of course, that means all that include neuroscience, of course, and we have an agreement, tight agreement with the University of Bordeaux, and we release the double title of the PhD in neuroscience, and this is an agreement that was established more than 10 years ago, and there is a framework agreement that works properly, and there is an interchange between our students and the University of Bordeaux, of course, and this is a typical example of network with European universities in the field of PhD programs. The University of Catania in the last years get a lot of fellowship, and for PhD students focused on a specific project. This we call industrial PhD programs that the idea basically are supported by the government and the Ministry of Economics, and the original idea was to focus the PhD project on a specific need of Italian industrial in the panorama of national Italian industry, and not only in national panorama. It's these programs are focused on specific projects, and the student have to do exactly the project. I mean, in the working plans, of course, and there is a strategic interest of some specific companies, of course. And the students have to, this is a mandatory, have to spend time in the company and a period in abroad in a different lab. And this is finalized for the specific project. And the idea of the Ministry of Economics here in Italy is that with this specific project, there is a improving and developing in the industrial field. So it is applied research, basically, and in different fields, of course. And this is what we have actually in Italy. And the students, of course, have the chance to meet the real world of the companies during the PhD program. And many of these students at the end of the PhD program found the work inside the companies are already embedded in the companies. So the idea was this. Today we will listen the experience of a couple of PhD students. Actually, one is a postdoc, but she accomplished the PhD program last year, and she had a nice experience on this industrial program of a PhD program. So, and before that, my colleague and friend Vito De Pinto will introduce some interesting aspect of the biotechnology PhD program. He is a coordinator of this program, and after that, PhD student will show and tell the experience inside of these industrial PhD programs, actually at the University of Catania. So this is just to give you a flower, an idea of this, how it works here at the University of Catania. This is industrial PhD programs. And of course, students from abroad, from US, or the whole Europe can apply on these programs, of course. And we, in the past, had a student from France and other countries. This is briefly what we do at University of Catania. And I will finish this brief introduction and I will ask to Vito De Pinto to introduce his PhD program and experience on that. I saw that also Vito De Pinto is Gabriel.
Hello?
I
am not Gabriel Moncalian. I am not can I share a presentation, a little presentation? So I will do in this way.
Please, Vito.
What to do? File. I don't know how to do box. Ok, ecco qua, Microsoft PowerPoint. I'm not very good with these methods of presentation, of sharing presentation. So I will, since the time is short, I begin to give you some information about the PhD program in biotechnology while I'm trying to share this presentation. So our PhD program, which is called in biotechnology, in general, biotechnology, is one of the youngest PhD program at the University of Catania. And it stems from a necessity that is clear for South Italian regions, which especially like Sicily and others, which are still in the one of the, let's say, less developed regions in terms of industrial and economic prosperity in comparison with the rest of Europe. So this is, let's say, a problem. So our mission is to try to improve the this potentiality. So the biotechnology program, PhD biotechnology program, is very general biotechnological program, and it is organized in four curricula that cover most of the biotechnological application. I don't know if can you see anything?
No, not yet, Vito. Sorry.
I don't know how to exactly do, but okay, it's a pity. Condividi, trying to share, but there is a. So we in Catania, we don't use this program, but we use Microsoft Teams. So we are not very, let's say.
You can you can press share screen in the middle bottom of your computer,
okay.
The green arrow.
Yes, and then there is desktop. There is another.
You can, yeah, you can press the first option, screen, and then you can open your presentation, and we will see the presentation.
No, I don't see screen, unfortunately.
The first option.
Okay, I go condividi schermo, then I have desktop.
Desktop.
Okay. And I say condividi, okay. Okay. I opened, but there is nothing in my, there is a privacy and safety windows, which is open. I don't know.
Può premere consenti, allow, se hai chiesto il permesso.
Okay.
Adesso riprovi a fare la stessa cosa, quindi sempre share screen e desktop.
Ok, di nuovo qua. Does not work. Okay.
Se vuole mi può inviare la sua presentazione tramite la chat e io la lancio.
Benissimo, allora facciamo così. Tramite la chat, dove caspita sta la chat? Eccola qua la chat.
In basso a destra c'è il segno di un foglio.
Allora. Ha sempre una serie di opzioni, invia chat a...
No, e un po' più sulla destra c'è il simbolo di un foglio. Se lei lo preme, gli appare un altro menu.
Dropbox, Microsoft, Google
Esatto,
Drive,
io il computer.
Computer. Troppe opzioni. Vabbè. Okay. Okay, so I'm sorry. So this is embarrassing, but
yeah, maybe you could try to explain everything without the presentation.
Okay. So I was trying to describe this this PhD program. So the PhD programs contains at least 30 professors of the University of Catania, which comes from different areas. In principle, there are professors from the agricultural area, from the pharmaceutical area, and from the biomedical area. So they are organized, the PhD program is organized in curricula, and the organization and the possibility. Oh, nice.
Yeah, now we see your presentation, Vito. Thank you.
Thank you. So, and
se clicca adesso sul centro dello schermo può controllare direttamente la presentazione, esatto. Aspetti che è uscito, fermi un secondo. Ok, avanti e dietro.
Okay. So this is the okay. This is some just line. These are the 4 curricula, and we got 8 industrial grants in the last 3 years, in this few years where we started to work. And in this industrial grants, one has to have a PhD student who is fulfilling a specific program, which is organized in an industrial training, or at least they stand in some industry for developing their scientific and research program for at least 6 months, and another 6 months are required of a stage abroad. Usually our students stay more than these periods, especially in the industry, because they are very much interested in developing their skills in a practical and in a competitive context of application of their programs. And usually these proposals are granted from say a program ruled by the state, by the ministry, which counts on sources, money is coming from Europe, but it is a competitive call. I mean that we make proposals for industrial PhD positions, but not all are accepted. They have to be screened, and they compete with other proposals from other universities, from other PhD programs. So in general, I can tell you that this is quite a good success for us to got to this 8th position in the last 3 years. Usually this proposal comes from previous established agreements that exist between professors and other and industry, local, especially local industries in several fields. And most of these agreements are established with national industries. So what I would like to outline before giving you some few examples of some of these kind of programs that we are developing in Catania, in the University of Catania, in the PhD programs, is the idea of the interdisciplinarity of biotechnology. Biotechnology is very generic terms if you don't fill it with real contents. For example, we say that the biotechnology has a kind of common field, which is the utilization, for example, of cells or living organisms for producing something like molecules or drugs or other things. So this is something where all the professors and all the curriculum find a common field, and this is also organized in the first year of the PhD program, when courses are given about genetic engineering or application of data mining in biological application, biological environment, and so on. And then another point which are now trying to develop is the internationalization of the PhD program in biotechnology, which is what I mean that we have already established a coordination with a PhD program in Spain. But since our kind of a PhD program is, let's say, quite unusual around, as I understood, around the world, because mostly are biotechnological programs focused on specific fields, like, for example, industrial or pharmaceutical biotechnology and so on, while our is very general. So we are thinking to establish different agreements, specific agreements with in the fields, in the different fields of our that are present in our organization. So, so we are really willing, and in this point, I would really have the help, and would like to work in the EUNICE cooperation to try to establish a larger PhD program where fields and research programs are shared between different PhD programs, to make a kind of a strict connection between groups and specific fields in different areas. So I will very briefly I have few slides just to show some examples of our programs, of our results. Can you please? Okay. So this is one field where we have some program, for example, tissue engineering and biomaterial engineering, which means that we try to produce molecules that can be used to replace or support damaged, in particular, arthritic cartilage. And okay, these are a flow chart of the different let's say, of the program, which is where cells are seeded in specific matrices, and these matrices and then colonized by the cells and then implanted in knee. This is one, for example, one biotechnological approach which is used in our doctorate. So another in a completely different area is in the agrarian area, is the study of specific crops that can be used to produce, for example, biogas, biodiesel, and so on. This is a very important program for Sicily, because there are several areas not cultivated or very dry, and the utilization of this area for growing specific plants that are not of let's say they're not can be used as food, but can be instead used as a starting material to produce biomass, is another very important, very interesting industrial application. Okay, these are some plans, and this is some example of how is what is the aims of this work to improve the yield of methane from starting from this biomass. This is another kind of study about, and you know that in Sicily there is a very strong production of lemon, citron, and oranges, and so on. And so these are studied also at the level of molecular biology to try to understand the rules of the biosynthetic pathway for the production of different molecules that gives flavors or colors to these fruits, and then to improve also the industrial utilization of these fruits. Very interesting, very important. And this is just to close, and just an example of a pharmaceutical development of a specific molecule. For example, these are histone deacetylase enzymes that are aimed to produce, to impact on specific kind of cancer, in this case, a specific kind of melanoma. So there are groups that produce and synthesize new molecules in the field of pharmaceutical chemistry. And and then of course, after the synthesis, there are the biological tests of these drugs. And just to finish, also another kind of synthesis, but this is, let's say, at the cross point between biomedical and pharmaceutical, because these molecules are radioactive molecules which are used for imaging of in positron emission tomography, for example. They are produced here in Catania in laboratory, and they are in this particular program they are aimed to localize hypoxia in tumor tissues. This is the synchrotron, which is based in the hospital of Catania, where the synthesis is performed. And okay, so these few slides were just to give you some ideas of the very broad range of activities of the PhD programs. Now we will present also a student of our PhD program will present her work, and from where you can appreciate the activity and at least in more detail in one of these programs. So I am sorry for these technical problems with the presentation, but I am also, of course, available for any question, and in future also for the possibility to collaborate and contact other members of the EUNICE consortium. Okay, thank you, Gabby.
Thank you very much, Vito, for your presentation. So now, as you said, we have two presentations by two industrial PhD students that I would just ask you to be as brief as possible in order to stick to the time. We are going to steal some time from the University of Canterbury, but please be as brief as possible. Matthias, Matthias has a question. Do you, Matthias, have a question, because you have your hand raised? Maybe not.
Yeah. But the microphone is closed.
Maybe later, because the first topic, it was very interesting. Maybe there could be some contact with this topic. Yes. Okay, good. Thank you, Matthias. Maybe later we could have some time for questions, because we are running. I'm sorry, we are running a little bit short of time.
So I suppose that now I have Paola in the screen. Isn't it, Paola?
Good morning.
Good morning, Paola.
Can you see my presentation?
Yes, thank you.
Okay. Good morning, everyone. My name is Good morning, everyone. My name is Paola Foti, and I'm a PhD student in biotechnology of the University of Catania. The PhD project, Olive Oil Byproducts as a New Functional Food and Source of Nutritional Food Ingredients, aims to valorize byproduct of virgin olive oil production. In this project, the partner is of the Department of Agriculture, Food and Environment, the Research Center for Oil, Olive, Fruit and Citrus Crops, the company Consoli Pasquale, and the Institute Polytechnic of Braganza in Portugal. In particular, the company Consoli is located in province of Catania and are one of the biggest olive oil companies present in Sicily. This industrial PhD is a multidisciplinary form of collaboration between university, research center, and the company, aiming at exploiting the research results in order to be more competitive advantage in production system. The valorization of byproducts is a functional strategy for the company to recover profits, reduce environmental impact, and obtain a new product. During extraction of oil, a large quantity of byproducts are generated. In particular, in my study, I focused on olive meal wastewater, liquid waste, and pate olive cake, solid waste. These byproducts are rich in the active compounds such as hydroxytyrosol and tyrosol, molecules with antioxidant activities. In this project, the olive meal wastewater were proposed a new fermented beverages. In particular, the matrix were treated with the carton filter to obtain a clear matrix and obtain a matrix free of solid suspended. In the last filter, I set up a new fermentation with microbial pool, combining the yeast and the acid lactic bacteria strains to obtain a new fermented food. In addition, olive meal wastewater were proposed a source of natural additives. In fact, this matrix has been subjected to a concentration process in industrial scale to use tangential filtration membranes. Different concentrates was added in food to fortify and formulate a new functional food. The second byproduct is pate olive cake that consists in pulp and vegetation water. This byproduct is obtained by the MF decanter, Linea Pieralisi series, present at the company. This is a machine two-phase system. The fermentation of the pate and direct guided fermentation with different strains in lab scale to obtain a creamy olive pate. The fermentation allows the bittering, stabilizing, increasing the nutraceutical value of final products. During all my work in company, I carry out different analyses such as chemical and microbiological analysis and tested the different activities of byproduct such as antioxidant and antimicrobial activities. Next step will be in company scale up of fermentation process of meal wastewater and pate, and formulation trial, a new functional food made from byproducts. Thank you for attention.
Thank you very much, Paola. for being able to summarize your work in just a few minutes. Thank you very much. So let's move now to Francesca. Francesca, are you there also?
Yeah, I'm here. Good morning. I have some problem with my webcam, so sorry for the for this technical issue. I don't know why, but I think that we are late, so I'm going to share my desktop with my presentation. Can I?
Please, Francesca.
Okay. Okay. Can you see my presentation?
It is starting. Yes, now perfect.
Okay, I will be very fast. So sorry for my face is not present in this presentation. Okay, I'm Francesca. I am PhD. I decided my PhD thesis last year. I work with Professor Bucolo, as he said before. This is the first slide of my PhD thesis dissertation of the last year. We study retinal disease, ocular disease. So we are studying ocular pharmacology in particular. So my thesis was aimed at the discovery of new pharmacological targets for the treatment, in particular in this case of diabetic retinopathy. So how did my project was constituted? So I've been for 1 year in this pharmaceutical company, SIFI. They produce a lot of ocular products. So I was able, thanks to all this company, to learn a lot of new methodologies of our type of studies, so in vivo and in vitro studies. I was able, in the meanwhile, to carry out some experiments about my PhD thesis. So I carried out experiment with cells with a particular type of hypoxia, or physiological hypoxia for retinal cells, just to complete and to going on with my PhD thesis. So after that, for 6 months, I've been in Florida at the Bascom Palmer Eye Institute in Miami with the Dr. Porciatti, where I carried out several projects. So at the end of the period, I was able with my group to do some publication about those projects. It was a very nice experience, not only in a human and life point of view, but in particular as regards as my work. Then for 1 year and 6 months, and I'm here until now, I'm a postdoc at the moment, and for 1 year and 6 months, I've been here at the University of Catania with a group of Professor Bucolo, where I was able to do these 2 works that constitute my my PhD thesis. So 2 different points, the study of 2 different points of view of diabetic retinopathy, and the discovery of new pharmacological target related to this disease. So those are the scientific publications that we carried out during these 3 years of not only regarding my PhD thesis, and obviously like the other students, I've been to several conferences. The last one before the COVID lockdown, I've been in Canada, at the Harbour Congress, and I won also a travel grant. So that's all by my side. Thank you.
Good. Thank you very much, Francesca.
You're welcome.
Thank you. Thank you very much.
Thank you.
So before moving to our last presentations, I think that we have time for Matthias to place a question right now. Matthias, are you there?
Yes, this is the first topic in this presentation. It was very interesting because we try to understand much more the behavior of bones, but bones alone is nothing. The surroundings are very important. And there already is a collaboration between us and Poznan. And this topic, what you represented, could be a very good extension of our investigation. And that's why it could be very necessary to have some idea about the things what there are done. And it is possible in the first moment only by email or some phone, but I think that it could be very fruitful.
Good. Yeah. Thank you, Matthias. Yeah.
Yes, thanks, Matthias, for your interest. Yes, I think that this is an example of what could be a common point of interest that on which we could try to build some also some programs, something which is related not only to industry but also to research and also to PhD education of PhD students. So we are very happy to have your contact and we can exchange mails at the beginning to understand how we can do, and maybe this can be one of the seed that we use to begin a more structured collaboration in the frame shift of EUNICE. Thanks.
I give you again this email of mine, and I'm looking forward. Very interesting.
Okay, thanks. Thanks.
Good. Yeah, this is also the idea of this workshop, not to find new ways of collaboration between each other. Good. Thank you very much again for all our 4 speakers from Italy. And now let's move to our last presentations today that are coming from the University of Cantabria. Dr. Rebecca Garcia Calderon, who is the Deputy Director for Competitive and Cooperative Research in the Knowledge Transfer Office, the University of Cantabria, is going to talk about industrial PhD programs in the University of Cantabria or in Spain. And finally, Cesar Aguado, who is an industrial PhD student working in BSH in an industrial company, will talk about his work. Thank you, Rebecca. The floor is yours.
Good morning. Well, I'm going to share a presentation.
Yeah, perfect.
Can you see? Okay. Well, as Gabriel has already said, I work in the Knowledge Transfer Office at the University of Cantabria. That is the unit in charge of managing the university call of the Industrial Doctorate Program. I would like to begin by explaining the reasons why the university decided to launch this call for grants. The reason is the belief that one of the most effective mechanisms to promote the transfer of knowledge between the academic and the professional environment is the recruitment by the company of highly qualified personnel trained in research and technological development tasks. This, together with the development of industrial doctorates at national and European level, understood as the training of a doctor who will develop his professional activity in the company, led the university to develop its own call to complement the national call. The main objective of the call is to promote within companies the training of doctors in the University of Cantabria research programs in any area of knowledge. For this, there are research projects linked to commercial industrial activity will be developed by a PhD student from a company. I mean, already working in the company. This project will end with a presentation by the PhD student of his doctoral thesis with the mention of industrial doctorate. The first call launched by the university was in 2014. And the main difference with calls of national level is that usually the offer grants are for hiring our researchers who will develop his doctoral thesis in the company, while this call is aimed at researchers who are already part of the company, staff, and therefore the grant is not intended to cover the hiring costs, but rather the expenses associated with the project they develop. The characteristics of the call are: it is funded by the Santander Bank and the University of Cantabria. It has annual periodicity. Currently, we offer 4 grants per call, and the financial aid amounts to 25,000 euros per grant, and the type of expenses it covers are registration fees and cost of issuing the doctoral degree, a minimum of 3,000 euros for the PhD student mobility expenses, like attendance at seminars and conferences related to the research project, stays in other companies, universities, and research centers. Expenses derived from the development of the research projects at the discretion of the thesis supervisor, for example, equipment, travels, and seminars. The projects will have a duration of up to 3 years if the doctorate is carried out full-time, or 5 years if it carried out part-time. In all cases, the defense of the thesis implies the end of the project. The requirements for the company are, it has to be a public or private company whose corporate purpose is industrial or commercial. The technology centers and technological innovation support centers can also submit an application. The company has to demonstrate sufficient innovative activity to justify the development of a research and development project with the University of Cantabria. The employment contract with the PhD students has to be long enough to guarantee the stability during the life of the project. The company must allow the dedication of the PhD student to the research project. The minimum gross salary of the PhD students, it must be 20,000 euro per year. And if the PhD student has a part-time contract, the salary and dedication might not be less than 3 fees. The requirements that the student must meet are: the student must be admitted or in the process of being admitted to a doctoral program at the University of Cantabria. The average grade of the academic record must be equal to or greater than 6 in a scale of 10. If the student is already doing the PhD, the time remaining until the thesis deposit date, must be equal to or greater than 2 years. And the presentation of the application implies the signature by the company of a collaboration agreement with the university within a maximum period of 1 month after the publication of the provisional resolution proposal in the terms collected in the call. The evaluation of the application is carried out in 2 phases, being the evaluation criteria the following. Phase 1 scores up to 5 points. The application must obtain a minimum of 3 points. And in this phase, they are evaluated the academic record, the CV of the PhD students, scholarship for initiation to research, hours, experience in relation to the thesis topic, business experience, research stays. Phase 2 scores up to 5 points and is valued in the research, development, and innovation activities of the company in the last 5 years, up to 2 points. Scientific interest and quality of the thesis project, up to 1 point. And research activities of the University of Cantabria Research Group in the last 5 years, and training capacity, up to 2 points. The benefits that the company obtains by participating in the program are: define together with the University of Cantabria the research and development project in which the thesis will be based, benefit from the transfer and ownership rights of the knowledge, technologies, and products obtained in its development, development, and to be identified and recognized as a collaborating company in the University of Cantabria Industrial Doctorate Program. In the case of the students, the benefits that the student obtains by participating in the program are obtained from the University of Cantabria the collaboration and support necessary for the normal development of his studies and research programs, compensation of the registration fees in the doctoral program, to be included in the research team of the project seen between the applicant company and the University of Cantabria, and participate in teaching and training tasks up to a maximum of 120 hours spread over the years of the grant, with prior authorization from the thesis supervisor and the department. The experience of the University of Cantabria results in 31 projects approved out of a total of 44 applications. We consider it as a success since the completion of an industrial doctorate under these conditions present many more difficulties than a pure academic PhD. Especially in these cases where applicants sometimes hold positions of responsibility within companies that make it difficult to reconcile doctoral studies with work. On the other hand, sometimes we find a lack of stability of the doctoral student in the company that makes it impossible to finish the project. Another problem is the lack of companies interested in hiring personnel with high scientific technical capabilities surrounding the University of Cantabria. Anyway, despite the difficulties, we believe that this type of initiative is important and will work to maintain the program in a stable way. Thank you for your attention.
Thank you very much, Rebecca, for your clear presentation about our industrial PhD programs in the University of Cantabria. Is there any question for Rebecca? Good. So now it is the turn of César Aguado. So he's going to be the last one, last but not least, of course, our last speaker, who is going to talk about his work in BSH as an industrial PhD student.
Okay, good morning. Can you hear me?
Perfectly, César, thank you.
Okay, I'm going to share my desktop that I think is shared right now, and I have to apologize because I'm in my desktop computer and I don't have a webcam right now, so you can only hear my voice. So okay, good morning to all, and I'm going to share you my thesis and my work here in BSH. I'm César Aguado. I'm working in BSH since, I started working here in BSH 14 years ago. And right now I'm doing my industrial PhD in the University of Cantabria in the mechanical department. So today we're going to see a very fast introduction of BSH, an overview of product development, because it's the driver or the motivation for this thesis. Then we will see the main or the core business of the thesis, that is going to be based in material model building. And finally, we will see how this thesis will contribute to the innovation in BSH. So BSH was founded in 1977 as a joint venture between Siemens and Robert Bosch, but since 2015 we are 100 Robert Bosch company. So we are the home appliance branch of the Bosch group. Right now we are the market leader in Europe, and we are second in the world. Right now we are close to 60,000 employees all over the world, and in our portfolio we have 12 different brands, including of course Bosch and Siemens. We are 8 companies in 48 countries and 40 factories around the world. Here in Spain, we are situated in Santander, in the north of Spain, and we are the competence center for developing gas technology. Apart of Santander, we have another six factories in Spain, situated around Zaragoza. So product development. Product development process is that process that involves all the steps needed to take a product from the idea to the market. We, as a development center, we have two main goals to be able to accomplish this process. That is to own the technology of the product. That is quite important, and of course to develop the projects within a tight milestone. As you can see in the chart, at the end of the project is where we found all the high efforts together with high cost. This is due to only at this stage is where final parts are available for testing. And of course, a failure in testing in this stage could lead to a catastrophic delay in project schedule and in cost. So the only way to avoid the testing in this final stage is to go virtual, which means to implement the use of numerical simulation. Sorry, okay. In BSH Santander, we develop gas cooktops, and the main part of this type of cooktops is the top sheet. This part is made of a 0.8 millimeter stamped steel sheet, which has to support high thermal loads that usually lead to large deformation in the part. These deformations are not allowed by the regulation. So if the part has this kind of huge deformation, we have to modify it, and which implies tooling modification, which has a huge impact in time and cost. That's why we need a numerical tool that anticipates the thermal load deformation before tooling, due to this high cost and time consuming. No? And of course, to generate or to build this numerical tool has a lot of challenge. Maybe the biggest is the material modeling. We have to find some material models that are able to mimic the behavior of the steel, and then we have completely different kind of simulation, as is stamping and trimming. Of course, we have to lead with the springback simulation. That is a problem that is not completely solved for this kind of steels. Then we have to lead with stress mapping, because we are going to run simulation, to run a chain of simulation. So we have to take results from one simulation, go to another simulation, and this implies to do some stress mapping. And of course, we have to deal with different kind of solvers, like it's the implicit and the explicit solvers, depending on which stage we are working. In order to solve this topic, we have designed a three-stage workflow. The first one is the stage where we are going to build the structural model of the part as a single component. So here in this stage, we are going to model our material. We are run a stamping simulation, continue with a trimming simulation, and then a springback simulation. And from here, we are going to get all the residual stress that the parts are supporting. With these stresses, we will go to another simulation where we assemble this part with the rest of the parts of the cooktop. So we are going to have the structural model of the appliance. And finally, in another simulation, we are going to couple the mechanical simulation with the thermal simulation in order to get this deformation with the thermal loads. But the thesis is going to be focused in the first stage and, of course, in the material modeling. Okay, the material model is a numerical engine that describes the behavior of the real materials. All material models are built from the extraction of the material properties or the mechanical properties of the material. With these mechanical properties, we build different kinds of material models that they are going to be as a candidate to be our material model. With this material model, we are able to simulate very specific testing of our material, and from this simulation, we are going to obtain some numerical results. At the same time, we are doing testing testing experiment. We get the specimen, measure the specimen, and we obtain the experimental results. Finally, we put together all the numerical and experimental results, and we compare the results, and we choose the best material model for our application. This is how the all material models or the actual material models are developed. But right now we are working with very modern steel that have very complex behavior. For example, our material, our austenitic steel that we are using in our products, for example, have some phase transformation when we deform the steel. So at the moment that we are stamping this material, is transforming in another material, more or less, is kind of an approximation. Then we have the Pausinger effect, that is we are going to face to an asymmetric behavior. Instead of we are compressing in a tensile stress or in a compression stress. So this is something that our material model have to deal with. And finally, or another complex behavior that we have to model is the variation of the Young modulus with the plastic strains. So at the moment that we deform our material, the Young's modulus is changing, and in a stamping process, a part has different plastic strains in different zones of the part. So we have to face two different Young modulus in the same part. And the only models that are able to capture this behavior, this complex behavior. For example, we are going to use Yoshida Urimori model that assume this kinematic hardening, for example, and this is doing by mathematical modeling. And the problem of this is that we have a lot of different coefficients in order to fulfill this material model that don't have any relation with the mechanical properties of the material, and this is quite difficult in order to relate the material properties and our material model. And how we solve this problem? Pues only with optimization. With the grant that we have from the University of Cantabria, we are developing some tooling in order to generate hundreds of different specimens. We are going to measure these specimens, and we are going to have a huge data bank of different force curves, shapes of the parts. With all this data bank, we are going to run a lot of neural networks, genetic algorithms, and Monte Carlo simulation in order to generate all these material models, all the data that we need to build this material model. So finally, when we finish our thesis, we expect to have an accurate sprint back results, because we are going to build a very complex material model. So we expect these accurate sprint back results, and of course a fast and low material modeling, because it's very important to be able to build material models, to build a complex material model in a fast and a low cost way. And all this will lead to innovation for BSH. In the moment that we have these material models, we'll be able to have a product development by simulation. We will be able to reduce development time and cost, increase our competitiveness, and of course, better quality products. More or less, this is all. So thank you.
Thank you very much, Cesar, for your presentation and for showing us the work that you are doing in VSH in order to get your PhD. Is there any question for Cesar or for Rebecca about industrial PhDs in the University of Cantabria? Matthias also has a question. Matthias, please.
Do you have any paper about it? Because it is very interesting, because you can imagine that material behavior is for us very interesting. And several years ago, I worked also in metal forming. It would be very interesting to read something, and I see there's a possibility, could be a possibility.
Yes, my first paper will be finished, I expect, at the end of this year.
Okay. I give you this my email address.
Okay.
And maybe we could correspond.
Yes. I will respond to you
because
later.
Metal forming in the moment it is not so the topic, but maybe forming in relationship with this 3D printing materials. This is interesting, and that's why it could be very interesting for us in the future.
Okay, thank you. I will respond to you later.
Thank you.
Great, thank you, Matthias. So there's another question by Alberto. Alberto?
Very nice presentations, Cesar, and all the people. No, it's just a very general question. How is the relation between the coordination of the university and the coordinator or responsible at the there are any problems, any challenges? Which is your idea about the coordination of these two supervisions?
The question is for me?
Yes, for example.
Okay. It's okay. I have a very good relation with my thesis coordinator, my thesis director, and here in the factory, more or less, I don't have any coordinator because I'm the responsible of the mechanical simulation. So more or less, it's me at the same time, the student, the coordinator, and the employee.
So it's easy in that case.
Yes.
Thank you.
Okay, good.
Okay, thank you.
Is there any other question? Okay, good. So if there are no further questions, I think that we are already out of time. But at the end, I'd like to thank again all our speakers today. I think that it has been a very intense meeting, a very intense workshop, but it was really fruitful, at least for us, for me. And I think that it is good to have this first stone for a future collaboration between all the 7 PhD schools within EUNICE. And hopefully the next time we will have a face-to-face meeting that at the end it is going to be better for all of us. So thank you for the speakers, thank you for the students, thank you for the other participants, and have a nice evening or afternoon, all of you. Thank you.
Thank you.
Okay, thank you.